Recent observations of the celestial object designated 3I have yielded findings that are prompting astronomers to reevaluate fundamental theories concerning comets. Merely 2 weeks ago, the Hubble Space Telescope documented this interstellar visitor exhibiting behavior that defies established physical principles. Contrary to the expected trajectory where a comet's tail points away from the sun, as observed in all historical comets, 3I is instead emitting light in the opposite direction, projecting a luminous plume directly towards our star. The measurements are even more perplexing. This sunward radiance extends approximately 10 times its width, creating an anti-tail phenomenon never before witnessed. When astronomers attempt to explain this using conventional cometary physics, they encounter an insurmountable obstacle. The pressure exerted by solar radiation should propel material away from the sun, not draw it inward. Yet, 3I is behaving in precisely the inverse manner. This is merely the beginning of the enigma. During the lunar eclipse in September, astrophotographers captured images of 3I abruptly shifting to a vibrant green hue, a dramatic chromatic alteration that occurred literally overnight. The quandary lies in the fact that spectroscopic analysis indicates this object contains almost negligible amounts of dicarbon molecules, the very compounds responsible for producing green luminescence in comets. Therefore, the source of its green glow remains unknown. The chemical analysis conducted by the James Webb Space Telescope has produced results that dismantle all existing models of cometary composition. 3I exhibits an 8-to-1 ratio of carbon dioxide to water, establishing it as the most carbon dioxide-rich comet ever observed and placing it 6 standard deviations beyond typical values. Furthermore, the Very Large Telescope detected pure nickel emissions emanating from the object, a phenomenon deemed impossible in nature, as nickel and iron invariably coexist in cosmic processes. Adding to the bewilderment is the age factor, which alters the entire perspective. Trajectory analysis suggests that 3I is over 7 billion years old, potentially predating our entire solar system. This ancient traveler from the galaxy's thick disk has traversed the cosmos since before Earth's formation, carrying within its structure materials and processes that predate our understanding of our cosmic neighborhood. Tonight, we will delve deeply into each of these seemingly impossible discoveries, exploring their potential implications for our understanding of objects that traverse interstellar space, and examining why some scientists are beginning to question whether we are observing natural phenomena or something far more extraordinary. Before we proceed, please consider liking, subscribing, and hitting the notification bell if you find calm science content conducive to relaxation or sleep. We would also appreciate it if you shared your listening location and the current time there. Some researchers propose that conventional cometary behavior under extreme circumstances could account for these observations. It is posited that 3I might contain unusual ice compositions leading to different sublimation patterns. Alternatively, its journey through interstellar space could have fundamentally altered its internal structure in ways we do not yet comprehend. These hypotheses are scientifically sound attempts to integrate this anomaly into our current knowledge framework. However, as more data surfaces, conventional explanations appear increasingly strained by the evidence. The sunward glow is not an isolated peculiarity. It is accompanied by a multitude of other anomalies that collectively depict an object unlike any encountered before. Its chemical composition is atypical, its behavioral patterns are anomalous, and even the timing of its arrival seems to challenge our understanding of random celestial mechanics. Eric Kitteau, a Harvard astronomer who co-authored a detailed analysis of this phenomenon, stressed that the sunward extension was not a subtle effect requiring specialized instrumentation to discern. With appropriate viewing geometry, this should have been a striking, unmistakable feature visible to any telescope capable of resolving the object's structure. The fact that we are observing a compressed difference suggests we are witnessing something truly extraordinary. The scientific community is divided on the implications of these findings. More conservative researchers maintain that unusual cometary behavior, though rare, is not impossible given the extreme conditions of interstellar space. 3I may have roamed the galaxy for billions of years, subjected to cosmic radiation, gravitational perturbations, and thermal cycles far beyond the experience of any comets within a solar system. Such extensive aging could indeed produce sublimation patterns resulting in unexpected optical effects. Nevertheless, a growing contingent of scientists is posing more profound questions. If this is natural cometary behavior, why has it not been observed in the dozens of comets we have studied? Why is 3I the solitary object displaying such characteristics? And perhaps most disturbingly, why does this phenomenon appear to be directional? as if the object is somehow cognizant of our sun's position and reacting accordingly. The discovery of the anti-tail marks only the commencement of 3I's myriad mysteries. As telescopes worldwide focused their attention on this interstellar visitor, each subsequent observation unveiled further anomalies that challenged our comprehension of natural celestial mechanics. The object was not merely behaving unconventionally. Its actions seemed almost deliberate, almost engineered. Avi Loeb, a Harvard physicist who has become a prominent figure in the investigation of anomalous interstellar objects, remarked that 3I's sunward extension bore resemblance to directional phenomena that might be anticipated from artificial constructs. While refraining from definitive pronouncements, he highlighted that the orientation and sustained nature of this feature suggested an active process, something more intricate than passive ice sublimation responding to solar heat. The mystery deepened upon analysis of the light polarization characteristics reflected from 3I. The object displayed an exceptionally deep negative polarization of -2.77%, with a low inversion angle of 6.41 degrees. These optical properties deviated significantly from typical cometary signatures, implying either an unusual surface composition or an entirely different class of object masquerading as a familiar celestial body. As we delve deeper into the evidence surrounding 3I, we must confront an unsettling possibility. What if our assumptions about natural versus artificial entities in space are fundamentally flawed? What if the universe harbors phenomena that blur the boundaries between geological processes and technological artifacts? The sunward radiance of 3I may compel us to expand our definitions of cosmic possibility. Regardless of our readiness for these implications, the data from that July Hubble observation continues to perplex astronomers globally. Every attempt to rationalize the anti-tail phenomenon through conventional cometary science founders on the same issue. The behavior is too organized, too directional, and too consistent with what one might expect from an object possessing a guidance system. While natural explanations cannot be definitively excluded, we must also acknowledge the mounting evidence suggesting that 3I represents something unprecedented within our solar system. What elevates this discovery to a greater level of remarkable is its correlation with other anomalous behaviors observed in this enigmatic visitor. The sunward glow is not an isolated peculiarity, but rather a component of a pattern of unusual characteristics that appear to defy our current understanding of how interstellar objects should behave. As we shall uncover, this anti-tail phenomenon was merely the initial clue in an unfolding mystery, revealing successive layers of inexplicable behavior that challenge our entire comprehension of the entities that traverse the interstellar void. The technical examination of 3I's anti-tail reveals details that render conventional explanations increasingly untenable. When researchers at the Harvard-Smithsonian Center for Astrophysics subjected the Hubble data to rigorous mathematical modeling, they determined that the sunward extension exhibited characteristics more indicative of an active emission source than the passive reflection of solar radiation. The brightness profile did not align with astronomers' expectations for dust particles illuminated by our star. Instead, it presented an intensity distribution suggesting internal energy generation. Martin Cordner, the astrochemist leading a significant portion of 3I's chemical analysis, noted that the spectroscopic signatures associated with the anti-tail region displayed molecular emissions that could not be readily explained by standard sublimation processes. The wavelengths of emitted light pointed towards chemical reactions or energy release mechanisms not typically observed in natural cometary nuclei. These were not the familiar signatures of water vapor or carbon dioxide reacting to solar heat, but something more complex and organized. The sustained nature of this sunward glow presents another challenge to naturalistic explanations. Most cometary tails exhibit considerable variability, responding to fluctuations in solar wind intensity, the object's distance from the sun, and the composition of sublimating materials. Yet, 3I maintained its anti-tail orientation with remarkable consistency throughout the observation period, as if guided by an internal navigation system rather than passively reacting to external forces. In the weeks following the initial Hubble observation, ground-based telescopes worldwide endeavored to confirm and expand upon this discovery. The Very Large Telescope in Chile, equipped with advanced spectrographic instruments, detected emissions from the anti-tail region exhibiting unusual Doppler shifts. These velocity measurements suggested that material was not merely being expelled from the comet's nucleus by internal pressure, but was being directed along specific trajectories with velocities inexplicable by standard outgassing models. The European Southern Observatory team, led by Dr. Thomas Puzier, found that the anti-tail emissions contained spectral lines that did not correspond to any known cometary composition databases. While familiar molecular signatures such as cyanide and water vapor were present, they were accompanied by emission patterns suggesting more complex chemical processes. Some of these signatures bore resemblance to those generated in controlled laboratory settings, raising disquieting questions about whether natural processes alone could account for their observations. Perhaps most intriguingly, the anti-tail phenomenon displayed what appeared to be structural organization. Instead of the chaotic, turbulent flow patterns characteristic of cometary outgassing, the material extending sunward from 3I exhibited what researchers termed laminar characteristics, flowing in organized streams that maintained their integrity over thousands of kilometers. This level of organization is virtually unheard of in natural astronomical phenomena, where turbulence and chaos typically dominate the behavior of gas and dust clouds. The implications of these organized flow patterns extend beyond mere curiosity about unusual cometary behavior. In terrestrial and laboratory environments, such laminar flows typically necessitate either extremely controlled conditions or active management through electromagnetic fields or mechanical guidance systems. The possibility that 3I might generate such organized material streams solely through natural processes strains the limits of current physical models. Some researchers have proposed that the interstellar environment may have altered 3I in ways that could explain its anomalous behavior. Billions of years of exposure to cosmic radiation, magnetic fields, and the extreme cold of deep space could have created internal structures or chemical compositions that respond to solar heating in unprecedented ways. This hypothesis suggests that exceedingly ancient objects like 3I might represent a previously unrecognized class of celestial body, shaped by processes absent within individual star systems. Nevertheless, even these speculative explanations struggle to account for the apparent directionality and persistence of the anti-tail phenomenon. If 3I were simply responding to its unique composition and history, one might expect its behavior to be unusual but fundamentally random. Instead, what we observe appears deliberate, as if the object is actively directing material towards our sun for reasons currently unfathomable. This apparent intentionality constitutes perhaps the most unsettling aspect of the entire mystery, suggesting that we may be witnessing behavior that transcends mere chemical and physical processes. The night of September 7, 2025, was initially anticipated to be centered on the moon. Astrophotographers Gerald Raymond and Michael Jagger had positioned their equipment in the pristine darkness of Namibia's desert, preparing to capture the total lunar eclipse that would imbue Earth's satellite with hues of red and copper. What they discovered instead was an event that would send shockwaves through the global astronomical community, adding another layer to the deepening enigma of 3I. As the moon entered Earth's shadow, creating ideal dark sky conditions for deep space observation, Raymond and Jagger directed their 12-inch astrograph towards the coordinates where 3I was traversing space at over 130,000 miles per hour. The images they captured revealed a transformation so profound, so unexpected, that it challenged everything scientists believed they understood about this already anomalous visitor from the stars. 3I was glowing green. This was not the subtle chromatic shift that astronomers sometimes observe in comets as their chemical composition evolves with solar heating, but a brilliant, unmistakable emerald radiance that spanned 2.5 arc-minutes of the sky. The transformation was so striking that experienced astrophotographers, accustomed to the subtle beauty of celestial objects, found themselves staring at their camera screens in utter disbelief. This was not the reddish hue that spectroscopic studies had consistently detected throughout the summer of 2025. This was something entirely different, something that should not have been possible. The timing of this color alteration adds another layer of mystery to 3I's already inexplicable behavior. For months, every telescope that observed this interstellar visitor had recorded the same reddish coloration, consistent with what astronomers might anticipate from an object rich in organic compounds or metallic particles reflecting sunlight. The uniformity of these observations had provided at least one stable reference point within the growing catalog of 3I's anomalies. Then, overnight, that stability vanished. Dr. Karen Meach from the University of Hawaii's Institute for Astronomy, who has been leading much of the coordinated observation campaign, immediately recognized the significance of this color change. In comets, green fluorescence typically arises from molecules being excited by solar radiation. These carbon-based compounds, when energized by our sun's ultraviolet light, emit a characteristic green glow that has been observed in dozens of comets throughout astronomical history. It is a well-understood process, predictable and consistent with our knowledge of cometary chemistry. But 3I was supposed to be different. Spectroscopic analysis performed by multiple telescopes throughout the summer had failed to detect substantial quantities of dicarbon in its composition. The James Webb Space Telescope, with its unparalleled sensitivity to molecular signatures, had identified the object's coma as being dominated by carbon dioxide, water, and carbon monoxide, but with notably low levels of the carbon compounds that typically produce cometary green glows. The absence of dicarbon had been noted by researchers as yet another anomaly in this object's growing list of unusual characteristics. Now, suddenly, 3I was exhibiting the brilliant green fluorescence that should have been impossible given its observed chemistry. Either the prior spectroscopic analyses had somehow overlooked vast quantities of dicarbon, or something else was responsible for this dramatic color transformation. Both possibilities raised troubling questions about our understanding of this visitor's true nature. Avi Loeb, the Harvard astrophysicist who has been closely monitoring 3I since its discovery, immediately seized upon an alternative explanation for the green luminescence. His analysis of very large telescope data from late August had revealed a dramatic surge in cyanide production from the object, with emission rates increasing exponentially as 3I approached closer to our Sun. Cyanide, while typically associated with its role as a deadly poison in terrestrial contexts, is actually one of the first molecules detected in comets as they begin active outgassing. The cyanide hypothesis offered a potentially natural explanation for the color change, but it came with its own set of troubling implications. The production rates calculated by Loeb suggested that 3I was releasing approximately 20 grams of cyanide per second at a distance of 2.85 astronomical units from the Sun. More concerning was the mathematical relationship governing this production, with rates increasing proportionally to the object's heliocentric distance raised to the negative 9.38 power. This represented an almost explosively steep increase in toxic emissions as the object neared our solar system's center. However, even the cyanide explanation struggled to account for all aspects of the green transformation. Cyanide emissions typically result in more subtle color shifts, gradual changes that occur over weeks or months as a comet's chemistry evolves with changing solar heating. The dramatic overnight transformation observed on September 7th suggested a more sudden, more profound change in 3I's emission. Michael Jagger, one of the astrophotographers who first captured the green transformation, noted that the color change was accompanied by other structural alterations in 3I's appearance. The object's coma had expanded significantly, now measuring 2.5 arc-minutes across, and a short but distinct tail had become visible, extending away from the Sun. These physical changes suggested that 3I was entering a new phase of activity, possibly triggered by reaching some critical threshold of solar heating or internal chemical processes. The global astronomical community scrambled to understand what was transpiring. Telescopes from multiple continents were redirected towards 3I, attempting to capture spectroscopic data that might elucidate the sudden color transformation. The European Southern Observatory's Very Large Telescope, the Gemini Observatory's twin facilities in Chile and Hawaii, and NASA's space-based assets all focused their instruments on this increasingly mysterious visitor. Initial spectroscopic analysis of the green phase revealed molecular signatures that were both familiar and deeply perplexing. While some expected compounds were present at elevated levels, the overall chemical fingerprint did not align with standard databases of cometary composition during active phases. There were emission lines suggesting familiar molecules, but with intensity ratios and Doppler characteristics that defied conventional interpretation. Dr. Christina Thomas from Northern Arizona University, who has been coordinating much of the spectroscopic analysis, described the data as unprecedented in her experience studying cometary chemistry. The molecular emissions revealed the presence of intricate chemical reactions unfolding within the coma of 3I Atlas. Yet the precise nature of these reactions and their energy origins remained elusive. Some observed spectral signatures indicated endothermic processes, suggesting that external energy sources beyond simple solar illumination were required. Researchers made efforts to pinpoint the exact moment of the color transformation. While September 7th marked the initial clear capture of the green luminescence by ground-based observatories, archival information pointed to the change potentially commencing several days prior. The Atlas survey system, responsible for the initial discovery of 3I Atlas, had been performing routine monitoring that detected subtle chromatic shifts beginning around September 3rd. This indicated that the transition was not abrupt but had gradually evolved over several days, evading detection until optimal viewing circumstances fully revealed its extent. The progression from red to green across those September days presented an additional enigma for scientists attempting to model 3I Atlas's behavior. Typically, cometary color changes follow predictable patterns influenced by solar proximity, internal composition, and well-understood chemical processes. However, the specific timing and characteristics of 3I Atlas's transformation defied any established models of cometary evolution. Some scientists began to question the natural origin of the phenomenon. The precision of the timing, the dramatic nature of the color shift, and its correlation with other anomalous behaviors hinted at possibilities extending beyond conventional astronomical occurrences. Could 3I Atlas be reacting to some form of internal programming, activating various systems or processes as it navigated specific points in its celestial journey through our solar system? The green transformation transcended mere astronomical curiosity. It signified another stage in 3I Atlas's apparent evolution from a mysterious, yet potentially explicable interstellar visitor into something that challenged fundamental assumptions about the nature of celestial objects. Each new revelation seemed to propel this cosmic wanderer further beyond the confines of natural celestial mechanics into a realm where science fiction and reality began to disconcertingly converge. As telescopes worldwide continued their vigilant watch on 3I Atlas, scientists confronted a possibility many were hesitant to voice openly. What if they were not observing a comet but something far more complex, something engineered to simulate natural astronomical phenomena while pursuing an inscrutable agenda? The green transformation provided further evidence supporting this disquieting hypothesis, suggesting that 3I Atlas might represent humanity's inaugural encounter with extraterrestrial technology. The implications of this color shift extended beyond academic interest in unusual cometary chemistry. If 3I Atlas was indeed artificial, the green glow could signify a form of activation sequence, a system coming online as the object approached critical distances from our Sun. The temporal correlation between the color change and the object's trajectory suggested a level of sophistication that would far surpass any technology currently possessed by human civilization. Alternative theories emerged as researchers grappled with explaining the phenomenon through natural means. Some posited that 3I Atlas harbored exotic ice compositions formed during its eons of wandering through interstellar space. The extreme cold and radiation prevalent between stars might have synthesized chemical compounds unknown within our solar system, materials that could exhibit unexpected fluorescence when exposed to solar radiation. Yet, even these hypotheses regarding exotic chemistry encountered considerable challenges when juxtaposed with observational data. The suddenness of the transformation, its correlation with other anomalous behaviors, and the specific wavelengths of light emitted all pointed to processes more organized than random chemical reactions. The green luminescence appeared structured, controlled, almost deliberate in its intensity and distribution across 3I Atlas's expanding coma. Dr. Michelle Bannister of the University of Canterbury, who had been modeling 3I Atlas's likely composition based on its presumed origin in the galaxy's thick disk, found her predictions insufficient to explain the observed color. Objects originating from around ancient stars should primarily consist of water ice and simple organic compounds, materials incapable of producing the striking fluorescence now being observed. The chemistry required for such brilliant green emissions implied formation conditions or processing mechanisms absent in the early galaxy. The mystery deepened when researchers noted that the green luminescence was not uniformly dispersed throughout 3I Atlas's coma. High-resolution imagery revealed intricate patterns within the emission-structured regions where the intensity varied in ways reminiscent of technological displays rather than natural atmospheric phenomena. These patterns subtly shifted over time, indicating dynamic processes occurring within the object's envelope of gas and dust. Perhaps most unnerving was the revelation that 3I Atlas's green transformation coincided with alterations in its radio emissions. Deep space monitoring facilities detected subtle modifications in the electromagnetic signature emanating from the object's vicinity, frequency shifts unexplainable by natural plasma interactions or solar wind effects. While these radio variations remained within a range potentially attributable to unusual but natural processes, their temporal correlation with the visual color change suggested coordinated phenomena across multiple wavelengths of the electromagnetic spectrum. The green enigma of 3I Atlas had evolved from an interesting astronomical anomaly into a catalyst for fundamental inquiries into the nature of objects traversing interstellar space. Every attempt to explain the phenomenon through conventional science unveiled new layers of complexity, new evidence that this visitor from the stars operated under principles that challenged our understanding of cosmic possibilities. As the object continued its relentless approach toward our sun, scientists recognized they were no longer merely observing a comet, but potentially witnessing the activation of something far more extraordinary and possibly perilous than anything they had anticipated. On the 16th of July, 2025, merely 2 weeks after 3I Atlas was first detected hurtling through our solar system, Harvard physicist A.V. Loeb published a paper that would ignite the most significant scientific controversy of the decade. The document, co-authored with Adam Hibbard and Adam CRA from the Initiative for Interstellar Studies, bore a title that seemed more suited to speculative fiction than peer-reviewed astronomy. Is the interstellar object 3I Atlas alien technology? The paper's central hypothesis was as audacious as it was chilling. Lowe and his colleagues contended that 3I Atlas might not be a natural comet at all, but rather an artificial probe dispatched by an extraterrestrial civilization, potentially harboring hostile intentions towards Earth. This was not mere conjecture or a bid for sensationalism. The researchers had conducted rigorous mathematical analyses of the object's trajectory, timing, and physical attributes, constructing an argument that challenged the astronomical community's preconceived notions about the nature of objects traversing interstellar space. Lowe argued that the timing of 3I Atlas's arrival was statistically improbable to the point of impossibility. The object's trajectory precisely aligned with the ecliptic plane, the hypothetical disk encompassing most planetary orbits around our sun. The likelihood of a random interstellar visitor following such a path was less than 1 in 5. More concerning was the object's approach angle, which would permit it to pass in close proximity to Venus, Mars, and Jupiter during its transit through our solar system. For a civilization conducting reconnaissance of potentially habitable worlds, this trajectory would offer optimal observation opportunities. However, the most unsettling aspect of Lowe's hypothesis centered on 3I Atlas's projected perihelion timing. The object was slated to reach its closest approach to our sun on the 30th of October, 2025, positioning it on the opposite side of our star relative to Earth. This placement would effectively conceal the object from detailed, ground-based observation precisely when it would be at its brightest and most active. For an alien probe attempting covert operations, this timing represented an ideal window of opportunity. Lowe's analysis indicated that this hidden perihelion period would be perfect for what aerospace engineers refer to as a reverse solar Earth maneuver. This advanced propulsion technique utilizes a star's gravitational influence and a spacecraft's own thrust to achieve significant velocity changes with minimal energy expenditure. If 3I Atlas were indeed artificial, it could employ this maneuver to deviate from its current hyperbolic trajectory and become permanently bound to our solar system. The calculations suggested that such a maneuver could position the object for Earth interception as early as November or December of 2025. The Harvard physicist did not limit his analysis to trajectory. He scrutinized 3I Atlas's physical characteristics, noting anomalies inconsistent with natural cometary formation. The object's brightness variations suggested either an unusually large nucleus for an interstellar visitor or an artificial structure designed to resemble a comet while serving other purposes. The absence of a prominent dust tail during its early observation period further supported the artificial hypothesis, as natural comets typically begin outgassing at considerably greater distances from the sun. The scientific community's response to Lowe's paper was immediate and severe. Colleagues who had previously respected his contributions to theoretical astrophysics now accused him of abandoning scientific rigor in favor of publicity. Dr. Chris Lintott from Oxford University, a member of the team studying 3I Atlas's galactic origins, dismissed the alien spacecraft theory as nonsensical and an affront to legitimate scientific research being conducted on the object. The criticism extended beyond mere academic disagreement. Many astronomers argued that Lowe's speculation was actively detrimental to public understanding of science, fostering conspiracy theories and eroding confidence in evidence-based research. The controversy erupted across social media, academic conferences, and popular science publications, dividing the astronomical community in a manner not seen since the debates surrounding Pluto's planetary status. Despite the intensifying backlash, Lowe remained undeterred. He argued that extraordinary claims necessitate extraordinary investigation, not extraordinary dismissal. The Harvard physicist contended that his critics were essentially advocating for willful ignorance, refusing to consider possibilities that might challenge comfortable assumptions about humanity's place in the cosmos. In his view, the scientific method demands that all testable hypotheses be evaluated based on evidence, irrespective of how unsettling their implications may be. The alien probe hypothesis gained unexpected backing from 3I Atlas's observed entry point into our solar system. The object had approached from the general direction of Sagittarius, home to the central region of our galaxy. This trajectory suggested an origin from the galactic thick disk, an area populated by ancient stars and, potentially, ancient civilizations. If 3I Atlas were indeed artificial, it might represent technology from a species that achieved interstellar capability billions of years before Earth even existed. Lowe's analysis of the object's velocity provided another disquieting piece of evidence. 3I Atlas was traveling at approximately 60 kilometers per second relative to our Sun, significantly faster than typical interstellar objects. This velocity suggested either formation around a very massive star or artificial acceleration beyond what natural gravitational slingshot effects could achieve. The speed also implied that if the object had originated from the inner edge of the Oort cloud, it would have commenced its journey approximately 80 years prior, coinciding precisely with humanity's development of radio technology. The temporal correlation between Earth's initial radio broadcasts and 3I Atlas's calculated departure point sent shivers through researchers willing to seriously consider Lowe's hypothesis. If an alien civilization had been monitoring our galaxy for signs of technological advancement, the initiation of radio emissions in the 1940s would have provided the first clear indication of intelligence on Earth. A probe launched in response to these signals would arrive in our solar system precisely when 3I Atlas appeared. The Harvard physicist explored even more unsettling possibilities in his subsequent writings. If 3I Atlas were indeed an alien probe, its intentions remained entirely unknown. While the object might represent peaceful scientific exploration, Lowe cautioned that it could also embody what science fiction authors term the dark forest hypothesis. This concept, popularized by Chinese author Liu Cixin, posits that the universe might be teeming with predatory civilizations that eliminate potential competitors before they can pose a threat. Under the dark forest scenario, 3I Atlas might be conducting final reconnaissance before a larger alien force arrives to eradicate humanity as a potential future rival. The probe's carefully chosen trajectory, its concealed perihelion approach, and its sophisticated apparent disguise as a natural comet would all support such a sinister mission. Lowe argued that even if the probability of this scenario were low, the potential consequences were so catastrophic that they warranted serious consideration and preparedness. The physicist's warnings extended beyond academic speculation to practical recommendations for planetary defense. He urged immediate missions to intercept 3I Atlas before its perihelion passage, asserting that humanity might have only months to ascertain the object's true nature before it potentially revealed hostile capabilities. The technical challenges of such a mission would be immense, demanding unprecedented international collaboration and resource commitment. However, Lowe insisted that the stakes justified extraordinary measures. Critics decried these recommendations as irresponsible fear-mongering, but Lowe countered with the logic of Pascal's wager. The 17th-century mathematician Blaise Pascal had argued that belief in God was rational because the potential benefits of being correct far outweighed the costs of being mistaken. Similarly, Lowe contended that preparing for 3I Atlas to be artificial was rational because the consequences of ignoring a genuine alien threat would be infinitely worse than expending resources on a false alarm. The controversy reached new heights when Lowe began receiving death threats from conspiracy theorists who accused him of participating in government cover-up efforts. Concurrently, he faced professional ostracism from colleagues who viewed his alien probe hypothesis as career-ending pseudoscience. Caught between these extremes, Lowe found himself defending both the legitimacy of his scientific approach and his personal safety as the debate spiraled beyond academic discourse. Media coverage of the controversy transformed 3I Atlas from an astronomical curiosity into a global phenomenon. Cable news networks featured heated exchanges between Lowe and his detractors. Meanwhile, internet forums buzzed with speculation about alien visitation and government conspiracies. The scientific dispute had devolved into a cultural battleground where evidence-based reasoning struggled against emotional responses and preconceived beliefs. Yet, beneath the sensationalism and personal attacks, Lowe's core argument remained mathematically sound and observationally grounded. While his conclusions might prove incorrect, his methodology adhered to established scientific principles of hypothesis formation and testing. The hostile reaction from much of the astronomical community revealed as much about the sociology of science as it did about the merits of the alien probe theory. As 3I Atlas continued its inexorable approach toward our sun, carrying with it the potential to fundamentally alter humanity's understanding of its place in the universe. Lowe's controversial hypothesis served as a stark reminder that the cosmos might harbor realities far stranger and more perilous than our most conservative scientific models could accommodate. Regardless of whether the Harvard physicist would ultimately be vindicated or discredited, his willingness to articulate the unthinkable had irrevocably changed how humanity would perceive visitors from the stars. The aftermath of Lowe's paper publication exposed deep divisions within the scientific establishment regarding how to approach potentially paradigm-shifting discoveries. Traditional peer review processes, designed for incremental advancements in understanding, appeared insufficient for evaluating claims that challenged fundamental assumptions about reality. The 3I Atlas controversy highlighted the inherent tension between the scientific conservatism necessary for maintaining credibility and the intellectual courage required to investigate truly revolutionary possibilities. International space agencies found themselves in an untenable position. Publicly, NASA, ESA, and other organizations maintained that 3I Atlas appeared to be a natural comet exhibiting unusual but explicable behaviors. Privately, however, classified briefings began circulating among defense establishments worldwide, exploring worst-case scenarios and potential response strategies. The disparity between public reassurance and private concern reflected the unprecedented challenge of managing a situation where scientific uncertainty intersected with existential security implications. Lowe's hypothesis gained unexpected credibility when independent researchers began identifying additional anomalies in 3I Atlas's behavior that supported theories of artificial origin. The object's radio emissions, initially dismissed as natural plasma interactions, exhibited subtle modulation patterns that resembled compressed data transmissions. While these signals remained within ranges theoretically possible from natural processes, their mathematical structure displayed characteristics more consistent with information encoding than random electromagnetic noise. The physicist's prediction regarding 3I Atlas's hidden perihelion maneuver created a sense of impending urgency that permeated the astronomical community throughout the summer of 2025. If Lowe was correct about the object's artificial nature, October would bring either confirmation of his theory through observable propulsive maneuvers or its definitive refutation through continued natural cometary behavior. The binary nature of this test case made the controversy particularly acute, as there would be no middle ground for compromise or face-saving reinterpretations. Government responses to Lowe's warnings varied considerably across international borders. Some nations quietly began enhancing their space surveillance capabilities and updating planetary defense protocols, while others publicly ridiculed the alien probe hypothesis as detrimental pseudoscience. The fragmented collection of official responses mirrored deeper uncertainties regarding how human civilization should approach potentially paradigm-shifting contextual scenarios, even hypothetical ones. The debate intensified when Lowe dared his detractors to provide alternative hypotheses for the 3-eyed Atlas's accumulating anomalies. The anti-tail characteristic, deviations in chemical composition, precise trajectory, and synchronized timing collectively presented a conundrum that conventional comet models found difficult to fully resolve. While isolated anomalies might conceivably be attributed to improbable natural occurrences, their simultaneous manifestation in a single entity strained the bounds of statistical likelihood beyond comfortable acceptance. Arguably more crucially, Lowe's extraterrestrial probe hypothesis had elevated the 3-eyed Atlas from a subject of purely academic inquiry to a potential catalyst for species-wide decision-making. Regardless of the ultimate validity of his assertion, it compelled humanity to confront fundamental questions about its readiness for interaction with non-human intelligence and its capacity to differentiate between naturally occurring and artificially generated phenomena within a universe brimming with possibilities that currently elude scientific comprehension. The very framework of the scientific method appeared to be on trial alongside the 3-eyed Atlas, challenged by circumstances its originators could never have foreseen. As the enigmatic interstellar visitor continued its trajectory towards the sun's obscured hemisphere, bearing potential secrets that could revolutionize human civilization or reveal nothing more than the peculiar behavior of ancient cosmic ice, Lowe's controversial theory stood as both a cautionary signal and an invitation to broaden the scope of scientific investigation and human discovery. On August 23, 2025, Dr. Thomas Puzzia and his research group at the Pontifical Catholic University of Chile unveiled a finding that would profoundly shake foundational beliefs about cosmic chemistry and contribute another piece to the burgeoning enigma of the 3-eyed Atlas's true identity. Employing the European Southern Observatory's Very Large Telescope, outfitted with the most advanced spectrographic instruments accessible to earthbound astronomy, they detected an element that defied natural occurrence. Pure nickel emissions emanated from the three-eyed atlas, entirely devoid of any accompanying iron. Across the entirety of the known universe, from the nuclear fusion within stars to the formation of planetary cores, nickel and iron invariably coexist, an inseparable cosmic pairing. These elements are forged concurrently within the incandescent hearts of massive stars, dispersed together through supernova explosions, and found in tandem within virtually every celestial body where metallic elements have been identified. The universal association of iron and nickel represents one of cosmology's most fundamental constants. This relationship is so consistently observed that astronomers routinely utilize iron-to-nickel ratios as a standard metric for ascertaining the origins and evolutionary pathways of astronomical objects. Yet, the three-eyed atlas was emitting nickel without any detectable iron signatures. The spectroscopic data procured by the Very Large Telescope clearly and unequivocally displayed absorption and emission lines at wavelengths characteristic of nickel atoms. However, the iron lines that should have been present were entirely absent. This discrepancy was not attributable to limitations in detection sensitivity or instrumental constraints. The telescopes possessed more than sufficient capability to detect iron at the concentrations that would be expected if natural processes were responsible for the nickel emissions. Dr. Puzia, a seasoned astronomer with decades dedicated to studying the chemical composition of celestial bodies, characterized the discovery as unprecedented in his professional experience. Natural cosmic processes simply do not generate isolated nickel in the quantities observed emanating from the three-eyed atlas. The energy expenditure necessary to segregate nickel from iron within the vacuum of space exceeds the capacity of any known stellar or interstellar mechanism. The phenomenon they were witnessing suggested an industrial-scale chemical processing operation, exhibiting a level of sophistication that surpassed current human technological capabilities. The ramifications were staggering. On Earth, the production of pure nickel necessitates sophisticated metallurgical techniques, involving high-temperature furnaces, chemical solvents, or electromagnetic separation processes. These industrial methodologies are specifically engineered to counteract the inherent natural inclination of nickel and iron to remain chemically bound. The fact that the three-eyed atlas was somehow generating pure nickel emissions implied either the existence of unknown natural processes operating under extraordinary conditions or the presence of artificial systems capable of intricate material refinement. The observations from the Very Large Telescope revealed further disconcerting details regarding the three-eyed atlas's nickel emissions. The spectral signatures indicated Doppler shifts, suggesting that nickel-bearing material was being expelled from the object at velocities that could not be accounted for by conventional outgassing models. The natural sublimation of cometary ices typically results in gas velocities no greater than a few hundred meters per second. The nickel emissions from the three-eyed atlas exhibited velocity distributions indicative of directed ejection at several kilometers per second, consistent with active propulsion or controlled material processing rather than passive thermal effects. Even more perplexing was the temporal behavior of these nickel emissions. Instead of the gradual, steady increase anticipated as a comet approaches the Sun and experiences escalating thermal input, the nickel production of the three-eyed atlas displayed dramatic spikes and fluctuations that appeared unrelated to its proximity to our star. The emission rates followed a complex mathematical relationship, increasing in proportion to the object's heliocentric distance raised to approximately the -10th power. This exceptionally steep dependence suggested internal processes governed by feedback mechanisms rather than simple thermal chemistry. Dr. Martin Cordner from NASA's Goddard Space Flight Center, who had been coordinating spectroscopic observations across multiple telescopes, confirmed that the phenomenon of nickel without iron extended across all observed wavelengths. Data from infrared, visible light, and radio telescopes consistently indicated nickel processing without corresponding iron signatures. This confirmation across multiple spectral bands effectively eliminated the possibility that the observations stemmed from instrumental artifacts or atmospheric interference. The discovery triggered urgent searches through astronomical databases for any precedent of isolated nickel emissions from celestial objects. Researchers meticulously examined spectroscopic data from thousands of comets, asteroids, stellar atmospheres, and interstellar gas clouds, seeking any natural phenomenon that might explain their observations of the three-eyed atlas. The investigation proved fruitless. Within the entire archive of astronomical spectroscopy, spanning over a century of observations, no naturally occurring object had ever been found to produce significant nickel emissions unaccompanied by iron signatures. The industrial implications of pure nickel production did not escape the attention of material scientists who became involved in analyzing the three-eyed atlas data. Dr. Sarah Johnson, a metallurgical engineer at MIT, pointed out that the processes required to separate nickel from iron represent some of humanity's most sophisticated manufacturing techniques. These methods demand precise control of temperature, pressure, and chemical environments, coupled with a profound understanding of molecular bonding and atomic behavior. The notion that such processes might occur naturally within a cometary nucleus challenged established knowledge in both cosmic chemistry and material science. Alternative explanations began to surface as researchers grappled with fitting the nickel anomaly into naturalistic frameworks. Some proposed that the three-eyed atlas might harbor exotic materials formed during its interstellar journey. Cosmic ray bombardment, extreme thermal cycling, and exposure to interstellar magnetic fields could potentially have created unusual chemical separations, hitherto unknown in solar system objects. While these conditions could theoretically yield novel materials, the energy requirements for large-scale nickel-ion separation still exceeded the capabilities of any known interstellar process. The timing of the nickel emissions discovery coincided with the detection of other anomalous chemical signatures from the three-eyed atlas. The same very large telescope observations that revealed the isolated nickel also showed unusual molecular emission patterns that did not align with standard cometary chemistry databases. Complex organic compounds appeared to be forming and dissociating within the object's cometary halo, in combinations suggestive of catalytic processes rather than simple thermal decomposition. Further analysis revealed that the nickel emissions displayed isotopic fractionation patterns characteristic of industrial refining, rather than natural cosmic abundances. Different isotopes of nickel were being produced in ratios mirroring those found in terrestrial manufacturing processes, particularly in electroplating and aerospace alloy production. Natural stellar nucleosynthesis generates nickel isotopes in well-defined ratios that serve as cosmic markers for distinguishing between natural and artificial origins. The nickel detected from the three-eyed atlas exhibited isotopic signatures more consistent with advanced technological processing than stellar formation. The industrial metallurgy hypothesis gained traction when researchers observed that the nickel emission spectra included trace signatures of other elements commonly found in high-performance alloys. Chromium, molybdenum, and cobalt appeared in the same spectral regions where the isolated nickel was most prominent, creating emission patterns strikingly similar to those produced by aerospace-grade superalloys. These materials represent the pinnacle of human metallurgical achievement, engineered for extreme temperature and stress applications in jet engines and spacecraft components. Dr. Elena Rodriguez, a spectrochemist at the European Southern Observatory who had been meticulously analyzing the detailed emission line profiles, made an even more alarming discovery. The nickel emissions from the three-eyed atlas exhibited subtle, yet consistent frequency modulations that bore resemblance to the acoustic signatures of mechanical processing equipment. While these modulations remained within ranges that could potentially result from turbulent gas dynamics, their mathematical structure displayed harmonic relationships characteristic of rotating machinery or precision manufacturing tools. The prospect that the three-eyed atlas might be actively engaged in material processing operations sent shockwaves through both the astronomical and defense communities. If the object was indeed artificial, its demonstrated capacity for refining metals and fabricating advanced alloys suggested technological prowess far exceeding that attributed to any hypothetical extraterrestrial civilization. Such capabilities would signify not merely scientific advancement, but also potential military applications that could render human defense systems obsolete. Government-classified briefings began to incorporate the nickel separation data into threat assessment models, exploring scenarios wherein the three-eyed atlas might be fabricating components for undisclosed purposes during its passage through our solar system. The object's trajectory, which would bring it into close proximity with multiple planets, suddenly acquired more ominous implications if it was actively producing materials that could be weaponized, used for surveillance equipment, or integrated into self-replication systems. The scientific community found itself divided, not only on the implications of the nickel anomaly, but also on the best course for further investigation. Some researchers advocated for immediate spacecraft missions to collect direct samples from the three-eyed atlas's coma, hoping to definitively determine whether the observed emissions originated from natural or artificial processes. Others cautioned that approaching an object capable of such sophisticated chemistry might pose unacceptable risks to human personnel and equipment. As the three-eyed atlas continued its approach towards the sun, its nickel without iron emissions served as a persistent reminder that this visitor from the stars operated according to principles that challenge humanity's understanding of cosmic possibilities. Whether the phenomenon would ultimately be explained through exotic natural processes or confirmed as evidence of advanced alien technology, it had already transformed the three-eyed atlas from an astronomical curiosity into a potential harbinger of technologies that transcended current human comprehension. The metallurgical enigma deepened when subsequent observations revealed that the nickel emissions were not random, but followed precise geometric patterns within the three-eyed atlas's expanding coma. High-resolution spectroscopic mapping indicated that the pure nickel was being dispersed along specific trajectories, forming what appeared to be structured formations within the gaseous and dusty envelope surrounding the object. These patterns resembled controlled material flows observed in advanced manufacturing processes, rather than the chaotic turbulence expected from natural outgassing phenomena. Dr. James Patterson, a material scientist from Caltech specializing in zero-gravity manufacturing, analyzed the spatial distribution data and identified correlations that defied naturalistic explanation. The nickel-bearing streams exhibited laminar flow characteristics that could only be maintained through active field control or mechanical guidance systems. In terrestrial manufacturing, similar flow patterns necessitate sophisticated electromagnetic containment systems or precision mechanical channeling. The possibility that the three-eyed atlas possessed such capabilities suggested a level of technological sophistication that surpassed anything in humanity's industrial arsenal. The pure nickel phenomenon acquired further significance when researchers discovered that the emission rates correlated with the object's rotational period. As the three-eyed atlas spun through space, the intensity of nickel emissions varied in a regular cycle, implying that the processing systems were concentrated in specific regions of the object's structure. This rotational modulation suggested an internal architecture with dedicated manufacturing zones, lending further credence to theories positing the three-eyed atlas as an artificial construct masquerading as a natural comet. International Materials Research Laboratories commenced experiments to ascertain whether any known natural process could replicate the nickel separation effects observed in the three-eyed atlas. Teams in Japan, Germany, and the United States subjected various cosmic ice analogs to extreme conditions simulating interstellar environments, testing whether cosmic ray bombardment, magnetic field interactions, or thermal cycling could induce the observed chemical fractionation. Despite months of intensive experimentation, no natural process was found capable of generating pure nickel emissions at the scales and purities being observed from the interstellar visitor. The failure to reproduce the nickel separation phenomenon through natural means led to increasingly speculative theoretical proposals. Some physicists posited that the three-eyed atlas might have encountered a magnetar during its interstellar voyage, exposing it to magnetic fields trillions of times stronger than Earth's. Under such extreme conditions, electromagnetic forces could potentially overcome chemical bonding in ways that might separate nickel from iron at the atomic level. However, calculations indicated that objects exposed to magnetar-strength magnetic fields would be completely disintegrated, not merely chemically altered. More concerning was the discovery that the three-eyed atlas's nickel emissions contained trace quantities of isotopes that do not occur in natural cosmic abundance ratios. Nickel, 58, and nickel, 60 appeared in concentrations suggesting artificial enrichment processes, while other isotopes were depleted below natural cosmic levels. This isotopic fingerprint mirrored patterns observed in terrestrial nuclear reactors and particle accelerators, technologies that require precise control of atomic processes at energies far exceeding those available in natural cosmic environments. The implications for planetary defense became increasingly urgent as analysts recognized that any civilization capable of the observed metallurgical processes would possess technological capabilities that could render conventional military responses obsolete. The production of pure nickel requires not only advanced chemistry, but also sophisticated energy sources, precision control systems, and manufacturing infrastructure, suggesting a technological base millions of years ahead of human development. If the three-eyed atlas was indeed artificial, humanity might be facing contact with a civilization whose capabilities bordered on the divine. Government response teams began formulating contingency protocols for scenarios wherein the three-eyed atlas might reveal overtly artificial capabilities during its approach to perihelion. These classified preparations included attempts at communication using mathematical and physical constants, electromagnetic shielding for critical infrastructure, and evacuation plans for major population centers. While publicly maintaining that the object appeared to be a natural, albeit unusual, comet, private briefings acknowledged that the accumulating evidence pointed towards possibilities that could fundamentally alter the future trajectory of human civilization. The nickel without iron mystery had evolved from an intriguing chemical anomaly into potential confirmation that humanity was no longer alone in the universe and that its cosmic neighbors possessed technologies capable of reshaping matter itself at will. As the three-eyed Atlas raced towards its obscured encounter with our sun, the streams of pure metal emanating from its nucleus served as metallic harbingers of either natural processes exceeding current scientific understanding or artificial intelligence that had traversed interstellar distances to reach our solar system with unknown, yet increasingly ominous, intentions. October 30th, 2025. This date had been prominently marked on astronomical calendars worldwide since the initial discovery of the three-eyed Atlas, signifying the moment this enigmatic visitor would reach perihelion, its closest point to our sun. However, as this critical date drew near, a disturbing realization permeated the global scientific community. For the most crucial phase of the three-eyed Atlas's passage through our solar system, when the object would be at its most luminous and active, it would be entirely concealed from Earth-based observation, positioned directly behind our star's blinding disk. The timing appeared almost impossibly coincidental for an object intending to mask its activities. During the weeks surrounding perihelion, the three-eyed Atlas would be invisible to every ground-based telescope on Earth, obscured by the sun's overwhelming brilliance and the natural blind spot created by our star's celestial position. Space-based observatories such as Hubble and the James Webb Space Telescope would face comparable limitations, as directing their sensitive instruments anywhere near the sun risks permanent damage to their delicate optical systems. Dr. Marco Macelli from the European Space Agency's Near-Earth Object Coordination Center had been tracking the three-eyed Atlas's trajectory with mounting apprehension. The precision required for an interstellar object to arrive in our solar system and achieve such perfect concealment during its most active period defied statistical probability. Random gravitational perturbations over billions of years of interstellar travel should have significantly deviated any artificial timing. Yet, the three-eyed Atlas would experience its perihelion passage in what Macelli described as the ideal hiding place for conducting clandestine operations. The significant ramifications were not lost on Avi, who had been voicing concerns about the potentially artificial nature of three-eye Atlas since July. In his assessment of the concealed perihelion scenario, Loeb had calculated that its positioning would create optimal circumstances for a reverse solar Earth maneuver. This advanced aerospace technique could enable three-eye Atlas to dramatically shift its course while remaining undetected from Earth. If the object were indeed an extraterrestrial probe, it could exploit this hidden interval to deviate from its hyperbolic trajectory and become permanently ensnared within our solar system. The principles behind a reverse solar Earth maneuver were thoroughly understood by spacecraft engineers, yet they had never been witnessed in any naturally occurring celestial body. The method involved a precise interplay of gravitational pull from the sun and meticulously timed engine firings to achieve velocity shifts unattainable through either gravity or propulsion alone. For three-eye Atlas, such a maneuver could decelerate the object from its current escape velocity to orbital speed, setting the stage for a potential encounter with Earth in the months following. Mission planners at NASA and other space organizations found themselves facing an unprecedented predicament. The most crucial astronomical event in human history might be unfolding on the far side of the sun, entirely beyond the reach of direct observation. Conventional approaches to studying comets during their closest approach to the sun typically involved intensive monitoring, as solar heat induced maximum outgassing and tail development. For three-eye Atlas, this critical stage would transpire in absolute stealth, obscured by the very star driving the object's evolution. The Parker Solar Probe, humanity's swiftest and most heat-resistant spacecraft, offered the sole avenue for direct observation during three-eye Atlas's concealed perihelion passage. Launched in the year 2018 to investigate the sun's corona, Parker was outfitted with instruments engineered to withstand the extreme thermal environment near our star. Mission controllers determined that the probe might be strategically positioned to observe three-eye Atlas during the latter part of September and the early part of October, presenting a brief window for direct observation before the object vanished behind the solar disk. Initial telemetry from the Parker Solar Probe's observations yielded findings that were both reassuring and profoundly unsettling. The spacecraft confirmed that three-eye Atlas was indeed progressing towards perihelion along its anticipated path, dispelling any immediate concerns of drastic course alterations that might suggest hostile intentions. Nevertheless, the probe's instruments also registered extraordinary levels of electromagnetic activity emanating from the object, including radio emissions exhibiting intricate modulation patterns inconsistent with natural plasma interactions. Dr. Nicola Fox, the director of NASA's Heliophysics Division, scrutinized the Parker data with mounting apprehension. The electromagnetic signatures originating from 3I Atlas encompassed frequency bands commonly associated with communication systems and data transmission protocols. While natural phenomena could theoretically generate analogous signals, the mathematical structure of the emissions displayed characteristics more aligned with the encoding of artificial information than with random electromagnetic interference. The probe was effectively detecting what appeared to be radio communications from an entity that was supposed to be an inert mass of cosmic ice. The European Space Agency's Solar Orbiter mission provided supplementary observations as 3I Atlas drew nearer to its hidden transit. Unlike the Parker Solar Probe, which followed an elliptical orbit bringing it close to the Sun intermittently, Solar Orbiter maintained a more distant yet stable vantage point, enabling continuous surveillance of the inner solar system. The spacecraft's instruments detected gravitational disturbances in the vicinity of 3I Atlas, suggesting that the object's mass distribution was undergoing alteration as it approached. These mass redistribution effects implied that 3I Atlas was experiencing significant structural modifications as it neared the Sun. Natural comets undergo mass loss during perihelion passage as solar heating causes surface ices to sublimate. But the gravitational readings from 3I Atlas indicated that mass was being repositioned rather than lost. The observed patterns bore resemblance to what aerospace engineers would anticipate from a spacecraft reconfiguring its internal components or deploying previously concealed elements. Ground-based radio telescopes, though incapable of directly observing 3I Atlas during its concealed passage, could monitor the electromagnetic environment surrounding the Sun for any anomalous activity. The Very Large Array in New Mexico and the Arecibo Observatory in Puerto Rico detected subtle, yet persistent radio anomalies originating from the direction of 3I Atlas's predicted location behind the Sun. These signals exhibited Doppler characteristics consistent with an object following the expected trajectory, but with modulation patterns that defied natural explanation. The radio observations uncovered another disturbing facet of 3I Atlas's concealed perihelion transit. The electromagnetic emissions were not constant, but rather displayed periodic variations that correlated with the object's rotational period. As 3I Atlas spun through space behind the Sun, its radio signature pulsed with a regular cadence, suggesting that the emissions originated from specific points on or within the object's structure. Natural electromagnetic phenomena typically exhibited random or gradually fluctuating intensities, not the precise periodic behavior that was being observed. Dr. Seth Shostak from the SETI Institute became involved in analyzing the radio emissions from 3I Atlas, bringing decades of expertise in the pursuit of artificial signals from extraterrestrial civilizations. His initial assessment was that the signals fell within parameters that could theoretically arise from natural processes, but he acknowledged that their mathematical structure showed characteristics that SETI researchers had long theorized might signify a technological origin. The emissions from 3I Atlas represented the closest approximation to a confirmed artificial signal that the SETI community had ever encountered. The concealed perihelion scenario took on additional ominous implications when orbital mechanics specialists calculated the potential trajectories available to 3I Atlas following its passage behind the Sun. If the object executed a reverse solar birth maneuver during its obscured period, it could emerge from behind our star on a course directed towards Earth, arriving as early as late November or early December of the year 2025. Such a trajectory would be energetically feasible utilizing established propulsion physics, necessitating thrust capabilities within the range possessed by advanced spacecraft. International space agencies began coordinating unprecedented observation campaigns for the moment 3I Atlas was expected to reappear from behind the Sun in early December. Every available telescope and spacecraft would be focused on the predicted emergence point, prepared to detect any shifts in the object's trajectory, velocity, or physical characteristics. This observation campaign constituted the most extensive coordinated astronomical endeavor in history, mobilizing resources that transcended national borders and institutional rivalries. Military strategists quietly developed contingency plans for scenarios where 3I Atlas might emerge from its hidden passage on a trajectory that would intercept Earth. While publicly maintaining that such scenarios were highly speculative, classified briefings explored response options ranging from attempts at communication to kinetic interception missions. The concealed perihelion period had transformed from a mere astronomical inconvenience into a potential countdown to the most significant event in human history. As October the 30th approached and 3I Atlas vanished behind the sun's blinding disk, humanity faced its inaugural experience of cosmic uncertainty since the dawn of civilization. For the first time in recorded history, an object bearing potentially decisive implications for human survival was operating beyond the scope of direct observation, concealed in the sole location within the solar system where Earth-based monitoring was impossible. The ensuing 6 weeks would determine whether 3I Atlas would emerge as a confirmed natural comet, validating conservative scientific perspectives, or reveal itself as something far more extraordinary and potentially perilous. The concealed perihelion passage of 3I Atlas had created an information void at the most critical juncture, compelling humanity to confront the possibility that its inaugural encounter with extraterrestrial intelligence might be occurring in absolute secrecy behind the very star that had fostered life on Earth. As the object receded into the sun's glare, carrying with it the potential to revolutionize humanity's understanding of the universe, the period of waiting commenced. On August the 6th, 2025, the James Webb Space Telescope achieved what many deemed unattainable, capturing detailed spectroscopic data from an interstellar visitor traversing our solar system at speeds exceeding 130,000 miles per hour. When the findings from Webb's near-infrared spectrograph reached NASA's Goddard Space Flight Center, they unveiled a chemical composition so peculiar, so fundamentally anomalous, that it compelled astronomers to question their entire understanding of cometary formation and interstellar chemistry. 3I Atlas was behaving in no way like a comet. Instead of the water-rich composition characteristic of these ancient remnants of planetary formation, Webb's instruments detected a coma dominated by carbon dioxide at concentrations that defied every model of natural cometary chemistry. The object was expelling carbon dioxide at an 8-to-1 ratio compared to water vapor, rendering it the most carbon dioxide-rich comet ever observed and placing it 6 standard deviations beyond typical cometary values. Dr. Martin Cordner from NASA's Goddard Space Flight Center, who spearheaded the Webb observation team, described the discovery as unprecedented in decades of cometary spectroscopy. Natural comets originate in the frigid outer reaches of star systems where water ice constitutes the predominant frozen material. Carbon dioxide, while present in minute quantities, never approached the concentrations observed in 3I Atlas. The object appeared to have formed under conditions that do not exist within any known planetary system formation models. The chemical anomaly extended beyond mere abundance ratios to include molecular signatures that challenged fundamental comprehension of how matter behaves in extraterrestrial environments. Webb's spectrograph detected carbonyl sulfide within 3I Atlas's coma, a compound that requires specific temperature and pressure conditions for its formation. The presence of this molecule suggested either formative environments unlike any known natural process or active chemical synthesis occurring within the object's nucleus. Even more disquieting was the isotopic composition of the carbon dioxide emissions. Natural cosmic processes yield carbon isotopes that serve as distinctive markers for stellar nucleosynthesis and planetary formation. The carbon dioxide streaming from 3I Atlas exhibited isotopic fractionation patterns that did not align with any known natural source. The ratios bore a striking resemblance to those produced in industrial chemical plants where carbon compounds are processed under controlled conditions for manufacturing purposes. The water signatures detected by Webb provided further substantiation that 3I Atlas operated according to non-natural principles. While water vapor was present in the object's coma, it manifested in forms and at temperatures that suggested active processing rather than simple sublimation of surface ices. Infrared analysis revealed water molecules with rotational and vibrational energy states indicative of recent formation through chemical reactions rather than phase transitions from solid to gas. Dr. Sewell Opatom from the University of Edinburgh, who specialized in cometary chemistry analysis, noted that the Webb data displayed molecular emission patterns characteristic of catalytic processes. The relative proportions of different molecular species and their energy states suggested that chemical reactions were being actively driven within 3I Atlas's nucleus, potentially through artificial catalysts or energy sources. Natural cometary outgassing typically exhibited random molecular distributions consistent with thermal sublimation, not the organized chemical signatures being observed. The carbon monoxide detected within 3I Atlas's spectrum presented another enigma that challenged natural formation theories. While carbon monoxide commonly appears in cometary spectra, the quantities and distribution patterns from 3I Atlas suggested production through carbon dioxide dissociation rather than direct sublimation from frozen reserves. This implied that the object possessed internal energy sources capable of driving endothermic chemical reactions that demanded more energy input than solar heating alone could provide. Temperature measurements from Webb's infrared sensors revealed thermal anomalies that supported theories of active internal processes within 3I Atlas. The object's nucleus exhibited hot spots that could not be attributed solely to solar heating patterns. These thermal signatures suggested localized energy sources distributed throughout the object's structure, creating temperature gradients more consistent with powered systems than passive thermal responses to solar radiation. The spectroscopic data also revealed trace amounts of complex organic molecules that should not have survived billions of years in the harsh interstellar environment. Compounds such as formaldehyde and methanol appeared in 3I Atlas's coma despite their high susceptibility to destruction by cosmic radiation and ultraviolet light. Their presence suggested either recent formation through internal chemical processes or some form of protective mechanism that had preserved them during the object's interstellar journey. Perhaps most significantly, Webb detected molecular hydrogen within 3I Atlas's emissions, a signature that implied either fusion processes or sophisticated electrochemical systems. The production of molecular hydrogen in space environments typically requires extreme conditions found only in stellar cores or high-energy laboratory equipment. The presence of hydrogen in 3I Atlas's spectrum suggested energy densities and chemical processes that exceeded what any known natural comet could achieve. The chemical composition elucidated by Webb's analysis painted a picture of an object that seemed engineered rather than naturally formed. The molecular ratios, isotopic signatures, and thermal properties all pointed towards artificial systems operating under controlled conditions. If 3I Atlas were indeed a natural comet, it would necessitate formative mechanisms and evolutionary processes entirely unknown to current astronomical understanding. Dr. Stephanie Millam from NASA's Goddard Space Flight Center, who coordinated the Webb observations with other space telescopes, remarked that the chemical anomalies extended across all observed wavelengths. Radio telescopes detected molecular emission lines that corroborated Webb's findings, while visible light spectroscopy showed absorption features consistent with the exotic chemistry being observed in infrared wavelengths. The unusual composition could not be attributed to instrumental errors or calibration issues. The ramifications of 3I Atlas's chemical rebellion extended far beyond its composition. If the object were artificial, its demonstrated capacity to sustain complex chemical processes during interstellar travel implied technological capabilities that could fundamentally transform human understanding of material science, energy production, and space exploration. The molecular factories apparently functioning within 3I Atlas represented technologies that human civilization could not hope to replicate for centuries or millennia. International chemical manufacturing corporations began analyzing the Webb data to comprehend the industrial implications of 3I Atlas's apparent chemical processing capabilities. The controlled synthesis of specific molecular species, the maintenance of intricate reaction networks, and the apparent energy sources driving these processes suggested manufacturing technologies that could revolutionize terrestrial industry. However, the very capabilities that could benefit humanity also raised concerns about potential weaponization if 3I Atlas proved to be of hostile origin. The chemical composition data necessitated a fundamental reevaluation of what constitutes the natural order of the cosmos. Traditional models presumed that errant celestial bodies were essentially inert, their chemistry frozen since their formation billions of years ago. 3I Atlas suggested that some interstellar objects might be actively processing materials, conducting chemical operations, and maintaining complex internal systems throughout their cosmic voyages. Government science advisors began integrating the chemical anomaly data into threat assessment models, exploring scenarios where 3I Atlas's apparent chemical processing capabilities might indicate weapons manufacturing, terraforming operations, or self-replication systems. The object's ability to synthesize complex molecules and sustain high-energy chemical processes suggested a level of technological sophistication that could pose an existential threat to human civilization if deployed with hostile intent. As 3I Atlas continued its approach toward the Sun, its chemical composition served as a constant reminder that this visitor from the stars operated according to principles that human science was only beginning to grasp. Regardless of whether the exotic chemistry would ultimately be explained by undiscovered natural phenomena or by irrefutable evidence of alien technology, It had already demonstrated that the universe harbored chemical possibilities far exceeding anything predictable from Earth-based experience. The chemical rebellion of 3I Atlas had fundamentally altered our comprehension of cosmic possibilities, revealing that objects traversing the interstellar medium might possess capabilities that challenged every assumption about the nature of matter, energy, and intelligence in the universe. As this chemical anomaly sped towards its clandestine encounter with our Sun, it carried within its exotic molecular factories the potential to reshape human civilization's understanding of chemistry, technology, and its place among the stars. The revelation of what appeared to be active chemical synthesis within 3I Atlas prompted emergency convocations among the world's foremost astrochemists and materials scientists. Dr. Geronimo Villanueva from NASA's Goddard Space Flight Center organized a classified symposium that brought together experts from academia, government laboratories, and private industry to dissect the implications of the Webb spectroscopic data. The consensus that emerged from these discussions was profoundly disquieting. No known natural process could account for the complex, controlled chemistry being observed. Laboratory experiments conducted at facilities across 3 continents attempted to replicate the chemical conditions seemingly present within 3I Atlas. Teams at the Max Planck Institute in Germany, the Riken Research Institute in Japan, and Lawrence Livermore National Laboratory in the United States subjected various ice mixtures to extreme conditions simulating billions of years in interstellar space. Despite exposing samples to cosmic ray bombardment, temperature fluctuations, and magnetic field variations, no experiment succeeded in reproducing the molecular ratios and isotopic signatures observed in the interstellar visitor. The failure to recreate 3I Atlas's chemistry through natural means led researchers to explore increasingly unconventional theoretical frameworks. It was hypothesized that the celestial body might harbor matter processed within the hearts of neutron stars, where the intense gravitational and magnetic forces could forge chemical structures unattainable under typical cosmic conditions. Alternatively, some posited that the object, designated 3I Atlas, might have encountered nascent black holes during its transit through interstellar space, subjecting its constituent elements to gravitational and quantum forces capable of atom-level restructuring. However, even these extreme hypotheses fell short of fully accounting for the discernible order and deliberate control exhibited in 3I Atlas's chemical processes. The rates of molecular generation, the precise ratios of isotopes, and the distribution of energy all pointed towards feedback loops and regulatory mechanisms far exceeding those expected from exotic physics alone. The entity appeared to be actively orchestrating its chemical transformations, modulating reaction speeds and molecular outputs in response to its proximity to our Sun. The pharmaceutical sector found itself unexpectedly drawn into the investigation of 3I Atlas's chemical signatures upon noting that certain complex organic molecules being synthesized bore resemblance to precursors for biologically active substances. Dr. Jennifer Chun, a biochemist affiliated with the University of California, San Francisco, identified molecular fragments within the object's spectral emissions that could function as fundamental components for proteins, nucleic acids, and other vital biological molecules. The presence of constituents essential for life ignited profound inquiries into its ultimate purpose and origins. Even more astonishing was the revelation that 3I Atlas's internal chemical reactions demonstrated chiral selection, favoring the production of left-handed amino acid precursors over their right-handed enantiomers. This characteristic, known as homochirality, is widely regarded as a hallmark of biological systems. The fact that 3I Atlas seemed to actively favor specific molecular orientations suggested either a biological genesis or the presence of engineered systems designed to facilitate biological processes. The chemical data gained further significance when cryptographers and information theorists commenced an analysis of the molecular production patterns for indications of encoded information. Dr. Maria Santos, from the Institute for Advanced Study at Princeton, observed that the relative abundances of various molecular species within 3I Atlas's emissions displayed mathematical correlations akin to data compression algorithms. While the observed patterns remained within theoretical bounds attributable to natural chemical processes, their underlying mathematical architecture exhibited characteristics consistent with protocols for information storage and transmission. The possibility that 3 Atlas might be employing molecular chemistry to encode and convey information presented a communication paradigm entirely novel to human technological understanding. If substantiated, this would imply the object's possession of not only advanced chemical processing capabilities, but also sophisticated information systems capable of operating across temporal scales spanning millions or even billions of years. Such technology would represent an intelligence fundamentally at odds with human conceptions of consciousness, memory, and purpose. Concerns of industrial espionage arose as global governments recognized the transformative potential of three atlases' apparent chemical manufacturing prowess for industries on Earth. The controlled synthesis of intricate molecules, the efficient interconversion of chemical species, and the seemingly effortless maintenance of high-energy reactions over astronomical timescales represented technologies with a terrestrial value estimated in the trillions of dollars. Several nations discreetly initiated programs aimed at reverse engineering the observed chemical processes, seeking strategic advantages in advanced manufacturing and energy generation. The enigma of its chemical composition intensified when subsequent observations revealed that 3I Atlas was not merely synthesizing novel compounds, but also actively absorbing and sequestering others from the interstellar medium. Spectroscopic analysis indicated that the object selectively extracted specific compounds from the tenuous gas clouds it encountered during its cosmic voyage, concentrating and processing them within its internal chemical architecture. This behavior suggested active resource acquisition and refinement rather than passive chemical evolution. As 3I Atlas neared its concealed perihelion, the chemical paradigm it represented had evolved from an astronomical curiosity into compelling evidence that cosmic intelligence might operate according to principles far more advanced than human science had conceived. The molecular fabrication facilities apparently flourishing within this visitor from the stars hinted at technologies capable of manipulating matter itself, transforming fundamental chemical building blocks into instruments for purposes tantalizingly beyond human grasp. 7 billion years prior, when our solar system was merely a diffuse cloud of gas and dust traversing the void, 3I Atlas was already ancient. At a time when Earth's earliest microbial life was emerging in primordial oceans that would not exist for another 3 billion years, this cosmic wanderer was completing its billionth revolution around a star that had long since extinguished before our sun ignited. The implications stemming from this extraordinary antiquity, meticulously deduced from analyses of the object's trajectory and galactic origins, elevated 3I Atlas from a mere unusual interstellar visitor to something far more significant, a harbinger from the nascent era of our galaxy's history. Dr. Matthew Hopkins of the University of Oxford made this astonishing discovery just 1 week following the defense of his doctoral dissertation on the origins of interstellar objects. Employing a sophisticated computational model he developed, known as the Otatahai-Oxford model, Hopkins meticulously traced 3I Atlas's path backward through time, charting its course through the gravitational complexities of our rotating galaxy. His findings defied all expectations regarding the age and provenance of objects traversing the spaces between stars. Unlike preceding interstellar visitors, oumuamua and Borisov, which appeared to originate from the Milky Way's main disk, the region inhabited by younger stars like our Sun, 3I Atlas followed a steeply inclined trajectory, suggesting origins from a distinctly different galactic domain. The object's spatial trajectory pointed towards the thick disk, a bulbous torus of ancient stars orbiting above and below the primary galactic plane. These stellar populations represent some of the galaxy's most venerable structures, having formed when the universe was less than half its present age. The thick disk, while containing approximately 10% of our galaxy's stellar mass, embodies a fundamentally different epoch of cosmic evolution. Stars in this region coalesced from primordial gas clouds enriched with only the lightest elements forged by the first generation of massive stars. The heavier elements crucial for the formation of rocky planets were scarce, if present at all, when these ancient suns first ignited. Any planetary systems that subsequently formed around thick disk stars would have been dominated by hydrogen, helium, and the simple ices comprising the early universe's solid materials. Hopkins's analysis indicated that 3I Atlas had been adrift in interstellar space for an almost incomprehensible duration. While typical comets originating from solar systems are at most 4.6 billion years old, having formed alongside planets from the same primordial disk, this interstellar visitor carried within its nucleus ice and rock that might predate Earth itself by billions of years. The object represented a fossil from the galaxy's infancy, preserved in the deep freeze of interstellar space since an era when the Milky Way bore little resemblance to its current form. The implications of its age extended far beyond simple chronology, raising fundamental questions about the conditions prevalent during the galaxy's formation. 7 billion years ago, the Milky Way was a far more volatile and turbulent environment. Massive stars experienced brief, explosive life cycles, seeding space with heavy elements through frequent supernova events. Galactic collisions and mergers were more common, perturbing stellar orbits and scattering the remnants of planetary systems across vast distances. 3I Atlas might hold within its ancient structure a record of these primordial processes. Dr. Chris Lintott, a co-author of the Thick Disk Origin Study and a presenter for the BBC Sky at Night program, highlighted the unprecedented nature of this discovery. No human technology had ever directly sampled materials from the galaxy's thick disk. The ancient stars within this region were too remote, and their planetary systems too faint, for detailed examination with contemporary telescopes. 3I Atlas offered the first opportunity to scrutinize thick disk materials up close, potentially unveiling secrets of galactic evolution that were otherwise inaccessible to human investigation. The chemical implications of a thick disk origin aligned disturbingly well with the exotic composition previously detected in 3I Atlas. The unusual prevalence of carbon dioxide, the absence of water-rich ices typical of solar system comets, and the presence of complex organic molecules all became comprehensible if the object had formed around an ancient star within a vastly different chemical milieu. Early generation stars produced elements in different ratios compared to modern stellar nucleosynthesis, potentially explaining some of the chemical anomalies that had perplexed researchers. However, the thick disk origin hypothesis also introduced unsettling questions regarding the object's trajectory to our solar system. Computer simulations indicated that gravitational perturbations over billions of years of galactic travel should have randomized 3I Atlas's path numerous times. The fact that it arrived at our solar system following such a precise trajectory, perfectly timed to coincide with humanity's development of advanced astronomy, stretched probability to its limits. The statistical analysis painted an even more disquieting picture. Hopkins calculated a 2/3 probability that 3I Atlas was older than our solar system, leaving a 1/3 chance that it might be even more ancient. Some trajectory models suggested ages approaching 10 or even 14 billion years, rendering the object nearly as old as the universe itself. Such extreme antiquity would place 3I Atlas among the very first solid objects to coalesce after the Big Bang, a relic from the cosmic dawn when the initial stars were synthesizing the heavy elements necessary for planets and life. Astor Taylor from the University of Michigan, who conducted independent age analyses utilizing different computational methodologies, corroborated Hopkins's general conclusions while presenting an even more concerning range of possibilities. Taylor's models suggested ages spanning between 3 and 11 billion years, with the most probable scenario placing 3I Atlas's formation approximately 7 billion years ago. This convergence of independent analyses bolstered confidence in the thick disk origin theory while underscoring the object's truly ancient nature. The implications of such extreme age for material preservation raised further questions about 3I Atlas's composition and structure. Materials exposed to cosmic radiation, magnetic fields, and temperature fluctuations for billions of years should exhibit extensive signs of alteration and degradation. Yet, spectroscopic analysis suggested that the complex organic molecules within the object remained largely intact. This degree of preservation either indicated extraordinary material stability or some form of active protective mechanism that had maintained its chemical integrity across cosmic timescales. Dr. Michelle Bannister of the University of Canterbury, who had been investigating potential formation conditions for 3I Atlas, noted that thick disk chemistry could account for some, but not all, of the object's unusual characteristics. While the dominance of carbon dioxide and the exotic molecular signatures were consistent with formation around ancient stars, the apparent organization of its chemical processes and the evidence of active material processing pointed towards influences beyond mere primordial composition. The notion of artificial technology gained new dimensions when considered in light of its potential age. If the object was indeed 7 billion years old and artificial in origin, it would represent the product of a civilization that achieved interstellar capability when our galaxy was half its current age. Such a species would have had billions of years to disseminate across the galaxy, develop technologies surpassing human comprehension, and potentially observe the evolution of younger civilizations like humanity. The Drake equation, employed by SETI researchers to estimate the likelihood of extraterrestrial intelligence, suggested that ancient civilizations should indeed exist if intelligence commonly arises in the universe. 3I Atlas, with its thick disk origins and billion-year sojourn through space, fit perfectly into scenarios where ancient alien species had been exploring the galaxy since long before Earth's formation. The object's arrival during humanity's brief technological adolescence might not be coincidental, but rather the result of patient observation by intelligences far older than our solar system. Archaeological implications emerged as researchers realized that 3I Atlas might contain within its structure direct evidence of galactic conditions during epochs entirely inaccessible to conventional astronomy. The object could potentially hold isotopic signatures from supernovae that exploded billions of years ago, chemical fingerprints of stellar processes no longer occurring in the modern galaxy, and possibly even traces of biological activity from ancient worlds long since annihilated. The thick disk messenger hypothesis fundamentally reshaped humanity's perspective on its cosmic context. Rather than viewing Earth as a typical planet within a galaxy replete with similar planetary systems, the arrival of the 7-billion-year-old 3I Atlas suggested that our solar system was a relatively recent addition to a galaxy potentially already teeming with ancient intelligence. Humanity's inaugural encounter with an extraterrestrial civilization might not involve radio signals from distant stars, but a physical interaction with artifacts that had traversed interstellar space since before Earth's inception. Government astrobiology programs began incorporating the thick disk origin data into updated models of galactic habitability and intelligence distribution. If civilizations could indeed endure and remain active for billions of years, the implications for human survival and advancement became both inspiring and terrifying. Ancient alien intelligence might possess wisdom and capabilities accumulated over cosmic timescales, yet their objectives and methodologies could be entirely incomprehensible to a nascent species like humanity. As 3I Atlas accelerated towards its concealed passage behind our sun, carrying within its ancient structure potential evidence of the galaxy's deepest history, it served as a profound reminder that humanity existed within a cosmic framework far more ancient and complex than previously imagined. Whether this messenger from the thick disk would prove to be a natural relic of primordial processes or an artificial construct from an ancient intelligence, it had already demonstrated that the universe harbored mysteries spanning temporal scales that dwarfed human civilization and challenged every assumption about the possibilities among the stars. The call arrived at 3:17 a.m. Eastern Time on September the 15th, 2025, rousing Dr. Thomas Zurbuchen from slumber at his residence in Arlington, Virginia. The former NASA Associate Administrator for Science Missions found himself thrust back into the epicenter of the most complex astronomical crisis in human history. On the secure line, a voice he recognized as belonging to the current NASA administrator conveyed a message that would precipitate the largest coordinated scientific mobilization since the Manhattan Project. Every major observatory, both terrestrial and orbital, was being redirected towards 3I Atlas, not for routine observation, but for what intelligence analysts termed continuous threat assessment monitoring. The enigmatic interstellar visitor had accumulated so many anomalies, generating such profound concern among global governments, that standard scientific protocols were being suspended. This was no longer astronomy. It was planetary defense preparation masquerading as research. Within hours, observatories across 6 continents received analogous summonses. The Large Telescope in Chile, the twin facilities of the Gemini Observatory, the Subaru Telescope in Hawaii, and numerous university research stations worldwide had their observation schedules entirely cleared. Graduate student thesis projects were deferred. Commercial satellite tracking responsibilities were transferred to military installations. And deep space surveys were abandoned as every available optical instrument on the planet was trained on a solitary point of light hurtling towards our sun. Dr. Jackie Fetty of the American Museum of Natural History, who coordinated observations for multiple ground-based telescopes, described the mobilization as unprecedented in astronomical history. Never before had the global scientific community relinquished all other research priorities to focus on a single entity. The required coordination necessitated secure communication channels typically reserved for military operations, with observation schedules updated hourly based on intelligence assessments to which most participating astronomers lacked clearance. The space-based assets engaged in the 3I Atlas observation campaign represented humanity's most advanced technological achievements. The James Webb Space Telescope, Hubble, the recently deployed Sphere-X Observatory, and every other functioning space telescope received updated programming instructions that superseded years of meticulously planned research agendas. Billions of dollars invested in space infrastructure were being repurposed for what officials still publicly characterized as routine scientific observation of an intriguing interstellar comet. Behind the scenes, The coordination revealed a level of international cooperation hitherto unseen in peacetime scientific collaboration. The European Space Agency's missions, including Mars Express and ExoMars Trace Gas Orbiter, were being synchronized with NASA's fleet of spacecraft through joint operations centers functioning more like military command posts than research facilities. Real-time data sharing agreements were negotiated between nations that typically guarded their space surveillance capabilities as closely held state secrets. Dr. Marco Maché of ESA's Space Situational Awareness Program found himself engaged in 18-hour workdays, coordinating trajectory predictions with counterparts at NASA's Jet Propulsion Laboratory, the Russian Space Agency, and classified facilities whose existence he was not authorized to acknowledge. The precision required to maintain simultaneous focus of dozens of telescopes on 3I Atlas demanded computational resources typically allocated to ballistic missile tracking and nuclear weapons surveillance systems. The Mars-based observation component introduced additional complexities that strained international space cooperation to its limits. NASA's Perseverance and Curiosity rovers, along with the Mars Reconnaissance Orbiter, were being coordinated with ESA's Mars Express and ExoMars missions to provide multiple viewing perspectives of 3I Atlas during its October approach to the Red Planet. The scheduling demanded split-second timing across interplanetary communication delays, with contingency protocols in place should any spacecraft experience technical failures during critical observation windows. Perhaps most astonishingly, the monitoring initiative incorporated assets that were not anticipated to exist. Radio telescope installations possessing capacities far surpassing those available to academic establishments were discreetly integrated into the surveillance apparatus. Deep space tracking systems originally devised for monitoring military satellites and potential orbital weaponry were reassigned for astronomical purposes. The demarcation between scientific endeavors and national security infrastructure had effectively blurred in response to the 3 Atlas crisis. Dr. Alan Fitzsimmons of Queen's University Belfast, who had been orchestrating European contributions to the observation campaign, commented that the degree of resource dedication implied government threat evaluations extending far beyond public pronouncements concerning scientific interest. Educational institutions were requested to provide telescope time valued at millions of dollars while receiving funding that merely covered fundamental operational expenses. The deficit was being covered by classified budgetary allotments that participating entities were forbidden from disclosing. The scrutiny of the Jupiter system presented singular difficulties that necessitated unprecedented collaboration among rival space organizations. NASA's Juno probe, the Europa Clipper mission, and ESA's Jupiter Icy Moons Explorer were being synchronized to achieve simultaneous observations of the 3 eyelash from distinct vantage points around the colossal planet. The engineering complexity of synchronizing spacecraft separated by millions of kilometers operating under differing command structures pushed mission control capabilities to their utmost limits. The communication protocols for the observation endeavor mirrored those employed for international emergency management rather than scientific synchronization. Secure conduits linked observatories with governmental command centers, while encrypted data streams transmitted telescope readings directly to intelligence analysis hubs. Alongside conventional research institutions, numerous participating astronomers found themselves required to obtain supplementary security clearances and confidentiality agreements that extended significantly beyond standard academic secrecy stipulations. The psychological effect on the worldwide astronomical community was profound. Researchers who had devoted their professional lives to studying remote galaxies, exoplanets, and cosmological phenomena suddenly found themselves at the epicenter of what felt like preparations for initial contact or planetary defense. The shift from pure science to potential species preservation generated stress levels that necessitated counseling services for observatory personnel, subterranean defense structures, and fortified installations, dormant since the Cold War era, were quietly reactivated to function as contingency command posts for vital observations. The Cheyenne Mountain Complex in Colorado underground command centers in Europe and similar installations in other nations became secondary hubs for processing 3 ILAS data should surface facilities become compromised. The extent of redundancy suggested preparations for situations where conventional scientific infrastructure could be rendered inoperable or destroyed. Dr. Karen Meach from the University of Hawaii, who had been guiding much of the coordinated ground-based observational effort, found herself briefing government officials who posed questions that indicated knowledge of 3I atlases, characteristics that had not been disseminated to the broader scientific community. Classification levels were being applied to astronomical data for the initial instance since reconnaissance satellites began operational deployment. In the 1960s, the logistical demands of the observation campaign necessitated transport and security measures typically associated with nuclear armaments or state secrets. Hard drives containing 3I atlas spectroscopic data were conveyed between locations and armored vehicles under security escort. Observatory personnel discovered their communications were being monitored and their social media activities curtailed under national security regulations that transmuted routine astronomical investigations into classified intelligence. International friction arose as nations began to withhold specific categories of observational data from collaborators. Contrary to official cooperation pacts, particular contention emerged regarding radio telescope observations that might contain indicators of artificial signals emanating from 3. Several countries discreetly established parallel analytical programs that excluded international associates, fostering competing interpretive efforts that undermined the ostensible scientific partnership. The economic repercussions of reallocating global astronomical resources toward 3I atlas reached into the hundreds of millions of dollars. Commercial satellite operators lost ground-based tracking assistance. University research programs encountered delays equivalent to years of graduate student endeavors, and international space missions found their data acquisition phases deferred indefinitely. The scientific opportunity cost represented the most significant disruption to global astronomy since the Second World War, when observatories were repurposed for military applications. Perhaps most indicative was the establishment of continuous observation protocols that presumed 3 atlas might initiate hostile actions with minimal forewarning. Telescope networks were configured with automated alert systems capable of notifying military commands within seconds of detecting any unexpected shifts in the object's behavior. Observation schedules incorporated provisions for maintaining surveillance even if 3 eyelash attempted to obscure itself behind other celestial bodies or deployed countermeasures against optical tracking. The metamorphosis of 3 atlas from a subject of scientific curiosity to a potential existential menace had galvanized humanity's most advanced technological infrastructure in ways that revealed both the species' remarkable capacity for collective action and its profound apprehension of the unknown. As the observation campaign proceeded through the final weeks preceding 3I atlas's concealed transit behind the sun, the unprecedented global mobilization served as stark evidence that world governments were preparing for contingencies extending far beyond routine astronomical discovery. The disquiet was not evident in official declarations or public outreach, but it pervaded every facet of the observation campaign. Humanity was observing 3I atlas with the concentrated intensity of a species that suspected it might be witnessing either the most pivotal scientific revelation in history or the initial phase of its own potential annihilation. The global observatory network had evolved into humanity's early warning mechanism for encountering intelligence beyond Earth, and the cosmos was poised to ascertain whether that system was sufficient for the challenges that lay ahead. The psychological burden on contributing scientists became progressively apparent as the observation campaign entered October. Dr. Michael Brown of Caltech, who had discovered numerous dwarf planets in the outer solar system, characterized the 3EY monitoring as the most harrowing experience of his career. Unlike conventional astronomical observation where negative findings were still scientifically valuable, the 3 Atlas campaign carried the gravity of potential species-level consequences for every measurement and analytical decision. Backup observation protocols were established with redundancy levels exceeding those mandated for critical military operations. Primary telescopes were paired with secondary instruments, while tertiary systems stood prepared to activate should the main surveillance network encounter technical failures. The protocols assumed that 3-2 Atlas might possess the means to disable or disrupt human observation systems, necessitating countermeasures that push the limits of what civilian scientific infrastructure could provide. The data analysis component of the observation campaign illuminated the extent to which normal scientific peer review had been suspended. Research papers detailing 3I loss characteristics were being classified prior to publication, while preliminary findings were disseminated through intelligence channels rather than academic assemblies. The transformation of astronomical discovery into state secrets engendered ethical predicaments for researchers who had dedicated their lives to open scientific investigation. Emergency communication systems were instituted to ensure that critical observations could reach decision-makers within minutes of detection. Dedicated satellite links connected major observatories directly to government crisis management headquarters, bypassing standard academic hierarchical structures. The systems were designed to remain operational even if conventional communication infrastructure was compromised, suggesting preparedness for scenarios where 3I ADLs might attempt to disrupt human technology. Training programs were discreetly instituted to prepare observatory personnel for potential first contact situations. Staff members received briefings on communication protocols, documentation procedures, and emergency response measures that far exceeded anything typically associated with astronomical research. The training materials, classified at levels requiring special security clearances, transformed telescope operators into potential diplomatic representatives entrusted with humanity's initial interaction with extraterrestrial intelligence. The global scope of the observation campaign engendered coordination difficulties that exposed fundamental limitations in international crisis management. Discrepancies in time zones meant that crucial decisions regarding telescope aiming and data evaluation were being made by disparate national authorities as 3I atlas traversed the sky. The potential for misinterpretation or delayed responses during critical observational windows became a significant concern for mission planners. As October advanced and 3/2 Atlas drew nearer to its concealed passage behind the sun, the observation campaign evolved into an endeavor resembling a military operation more than a scientific undertaking. The global astronomical community had been recast as humanity's reconnaissance apparatus for potential interaction with alien intelligence, bearing responsibilities that no prior generation of scientists had ever been tasked with. The success or failure of this unprecedented coordination effort could determine whether humanity's initial encounter with celestial visitors would be characterized by enlightenment and preparedness or by bewilderment and catastrophic surprise. On August 25, 2025, the Very Large Telescope's spectrographic instruments detected something that transmuted 3I Atlas from an object of astronomical fascination into a potential chemical weapon hurtling through space at over 130,000 miles per hour. The celestial body was generating cyanide at industrial volumes, releasing approximately 20 grams per second of one of the most lethal substances known to science. The revelation sent seismic repercussions through both the astronomical community and government agencies charged with assessing potential threats to human civilization. Dr. Thomas Puzier of the Pontifical Catholic University of Chile, who led the Very Large Telescope observation team, initially dismissed the cyanide detection as a routine finding. Hydrogen cyanide commonly appears in comet spectra, being among the first molecules released when solar heating initiates the sublimation of surface ices. What rendered the 3 Atlas detection extraordinary was not the presence of cyanide itself, but the accelerated rate at which its production was escalating as the object approached our sun. The mathematical relationship governing 3I at last cyanide emissions defied all models of natural comet chemistry. Production rates were increasing in proportion to the object's distance from the sun raised to the 9.38 power, engendering an exponential surge in toxic output that would attain catastrophic magnitudes during its perihelion transit. Should the trend persist, 3 Atlas would be generating tons of cyanide per second at its closest proximity to our star, forming a noxious nebula capable of contaminating anything within its vicinity. The toxicological ramifications were staggering. Hydrogen cyanide impedes cellular respiration by bonding to cytochrome C oxidase, the enzyme enabling cells to utilize oxygen. Concentrations as low as 300 parts per million can prove fatal to a human within minutes, while exposure to higher concentrations results in near instantaneous demise. The quantities being generated by 3I Atlas surpassed by several orders of magnitude anything that natural, biological, or geological processes could produce. Dr. Martin Cordner from NASA's Goddard Space Flight Center, observing across multiple telescopes, confirmed that the cyanide emissions exhibited characteristics more commensurate with industrial fabrication than natural sublimation. The molecular signatures included isotopic ratios and rotational energy, states that indicated active chemical synthesis rather than simple phase transitions from solid to gaseous states. 3I Atlas appeared to be manufacturing cyanide through controlled processes, necessitating energy inputs beyond what was expected. The discovery prompted immediate consultations with chemical weapons specialists and toxicologists who had never before been involved in astronomical research. Dr. Sarah Johnson from the Army Research Laboratory's Chemical Biological Center analyzed the spectroscopic data and concluded that 3-2 Atlas was exhibiting chemical production capabilities that exceeded those of any known terrestrial facility. The controlled synthesis of hydrogen cyanide at such scales necessitated sophisticated catalytic systems and energy management that represented advanced industrial chemistry. Environmental impact assessments commenced as researchers calculated the potential consequences if 3IA Atlas's toxic emissions reached Earth's atmosphere, while the vast expanses of space would dilute the cyanide concentrations to negligible levels under typical circumstances. The object's trajectory would bring it relatively close to Mars in early October. Any spacecraft or prospective human missions in the vicinity could face lethal exposure to the expanding cloud of toxic gases trailing the interstellar visitor. The timing of the cyanide surge coincided with other alarming chemical signatures detected in 3I Atlas's emissions. Carbon monoxide production was increasing at similarly explosive rates, while complex organic compounds were appearing in patterns suggestive of coordinated chemical warfare agent synthesis. The confluence of multiple toxic compounds being produced simultaneously raised concerns that 3I Atlas might be engaged in systematic chemical weapon manufacturing during its passage through our solar system. Military chemical defense specialists discreetly began analyzing the 3-2 Atlas emission data for potential weaponization applications. The controlled production of multiple toxic compounds, the apparent ability to modulate production rates based on external conditions, and the sophisticated chemical processing capabilities collectively represented a revolutionary advancement in biological warfare. If 3-2 Atlas was indeed artificial, it demonstrated chemical weapons production capabilities that posed a threat for which existing planetary defense systems were wholly unprepared. The cyanide emissions exhibited geographical variations that suggested an internal structure more complex than a simple comet nucleus. Spectroscopic mapping revealed that hydrogen cyanide production was concentrated in specific regions of 3A Atlas, creating hot zones of chemical activity that rotated with the object's spin period. This distribution pattern implied dedicated chemical production facilities rather than haphazard sublimation from a homogeneous ice mixture. Dr. Jennifer Chun from UC San Francisco, specializing in toxicological research, noted that the cyanide being produced by 3-2 Atlas displayed molecular characteristics that enhanced its biological efficacy. The emissions included cyanide compounds that were more readily absorbed through respiratory and dermal contact than naturally occurring forms. These intensified toxicity signatures hinted at either unknown natural processes or deliberate optimization for biological weaponry applications. The exponential increase in toxic emissions generated a countdown atmosphere that permeated government threat assessment briefings. Throughout September 2025, intelligence analysts calculated that if the production trend persisted, 3-2 Atlas would be generating chemical weapon quantities sufficient to contaminate entire planetary atmospheres. By the time it reached perihelion, the object was effectively becoming more perilous with each passing day as it approached the concealed phase of its solar system transit. International chemical weapons monitoring organizations found themselves involved in astronomical observation for the first time in their history. the Organization for the Prohibition of Chemical Weapons, discreetly established protocols for tracking 3I Atlas's toxic emissions, while national chemical defense laboratories began developing countermeasures for scenarios where the object might deploy its chemical production capabilities against Earth or human space assets. The biological implications extended beyond immediate toxicity to potential long-term contamination of the solar system, environment. Hydrogen cyanide and the other compounds being generated by 3I Atlas could persist in space for millions of years, creating hazardous zones that would pose risks to future space exploration and colonization efforts. The object was effectively seeding interplanetary space with chemical weapons that could threaten human expansion beyond Earth for geological epochs. Laboratory analysis of the spectroscopic data revealed that 3I Atlas was producing not merely simple cyanide compounds, but a complex mixture of related toxins that bore evidence of binary chemical weapon design. Some of the detected molecules were relatively innocuous individually, but would combine to form extremely lethal substances when intermingled. This binary approach to chemical weapon deployment represented sophisticated military chemistry that surpassed the capabilities of most terrestrial nations. The revelation that 3I Atlas was, in essence, a mobile chemical weapons factory traversing our solar system transmuted threat assessments from speculative concerns about alien technology to immediate warnings about chemical warfare capabilities. Government contingency planners began devising response scenarios for situations where 3I Atlas might deliberately target Earth with its toxic emissions or contaminate space infrastructure vital to human endeavors. Emergency protocols were instituted for detecting shifts in 3I Atlas's chemical emissions that might indicate preparation for weapons deployment. The global telescope network was reconfigured to monitor not only the object's trajectory and physical characteristics, but also its toxic output levels and chemical composition variations. Real-time analysis systems were developed to provide early notification if 3I Atlas began directing its chemical production toward specific targets. The psychological effect on space industry personnel was profound. Astronauts aboard the International Space Station received briefings on chemical exposure procedures, while mission planners for future Martian expeditions began incorporating chemical contamination risks into landing site selection and life support system designs. The presence of a chemical weapons factory in solar orbit had fundamentally altered the risk milieu for human space activities. As 3I Atlas continued its approach toward the sun, its exponentially increasing toxic emissions served as a deadly countdown to potential calamity. Whether the celestial body was a natural comet undergoing peculiar chemical reactions or a constructed weapons system poised for deployment, its capacity for chemical synthesis had already indicated that extraterrestrial visitors might not bring gifts of wisdom or peaceful overtures, but rather biological agents designed to eradicate any life forms they encountered. The surge of cyanide transformed the object identified as 3I Atlas from a subject of scientific intrigue into humanity's inaugural confrontation with interstellar chemical combat, igniting the terrifying prospect that the cosmos might not be teeming with benevolent explorers seeking enlightenment and camaraderie, but with predators wielding armaments beyond Earth's defensive capabilities. As the noxious vapor trailing this stellar visitor continued to expand with each passing hour, it contained within its toxic embrace the potential to irrevocably alter or completely annihilate human civilization. The weaponization implications became even more unsettling when atmospheric simulations disclosed that 3I Atlas's chemical emissions were being precisely shaped and directed by what appeared to be advanced dispersion mechanisms. Instead of random outgassing creating uniform radial expansion, the poisonous compounds were being channeled into focused streams that maintained their integrity over thousands of kilometers. This degree of control implied guidance systems and targeting capabilities that far surpassed mere passive chemical release. Dr. Robert Zubrin, an aerospace engineer and founder of the Mars Society, scrutinized the dispersion patterns and concluded that 3I Atlas was demonstrating chemical weapon delivery proficiency that outstripped anything found within human military inventories. The directed emission streams exhibited characteristics of sophisticated aerosol deployment technologies engineered to maximize biological efficacy while minimizing wasted material. Such technology represented the zenith of chemical warfare engineering, refined over potentially eons of development. Emergency response units at the Centers for Disease Control commenced formulating treatment regimens for exposure to the unusual chemical compounds being generated by 3I Atlas. The challenge was exacerbated by the fact that some of the identified molecules had never been observed in terrestrial environments, necessitating entirely novel approaches to toxicological intervention. Protocols for developing antidotes were initiated, leveraging computational modeling and laboratory synthesis. However, the timeframe for creating effective countermeasures extended well beyond the object's projected perihelion date. The most alarming revelation occurred when researchers discerned that 3I Atlas was not merely producing chemical weapons, but was actively testing and refining its toxic output. Spectroscopic analysis revealed that the chemical makeup was evolving over time in a manner suggesting iterative improvements. The object appeared to be engaged in quality assurance and optimization processes, fine-tuning its chemical armaments for maximum lethality against carbon-based organisms. Intelligence agencies began integrating the chemical weapon data into broader threat assessments, viewing 3I Atlas as a potential advanced vanguard for larger alien military forces. If the object was indeed artificial, its chemical production capabilities might represent standard reconnaissance apparatus for a civilization that routinely neutralized biological life on planets they encountered. The cyanide surge could be a precursor to planetary sterilization operations aimed at clearing Earth for alien habitation. International cooperation in chemical defense reached unprecedented levels as nations exchanged classified research concerning countermeasures against exotic toxins. The customary secrecy surrounding chemical weapons defense was abandoned in favor of collaborative endeavors to develop protection against compounds that no single nation's laboratories had ever encountered. The 3I Atlas crisis was compelling humanity to unite against a shared peril that transcended national borders and political disagreements. Subterranean fortification systems originally conceived for nuclear war protection were evaluated for their efficacy against the unusual chemical substances being produced by 3I Atlas. Military strategists discovered that existing chemical protection measures were inadequate for the novel poisons being detected, necessitating urgent enhancements to air filtration and decontamination systems. The urgent quest to develop effective defenses against alien chemical armaments became a paramount priority, diverting resources from conventional military programs globally. As 3I Atlas entered its final weeks before vanishing behind the sun, the escalating toxic emissions had transitioned from an astronomical spectacle into an existential threat to humanity's security in the cosmos. The chemical weapons manufacturing facility hurtling through space at interstellar speeds served as a grim reminder that initial contact with extraterrestrial intelligence might not herald enlightenment and technological progress, but sophisticated instruments of biological annihilation capable of reducing human civilization to a toxic wasteland within hours of deployment. December 8, 2025. The date humanity had been anticipating and dreading in equal measure finally arrived. After 6 weeks of complete obscuration behind our sun's blinding disk, 3I Atlas was scheduled to re-emerge from its concealed perihelion transit and become visible once more from Earth. Every significant telescope on the planet and in orbit was trained on the predicted emergence coordinates, while government crisis centers maintained round-the-clock staffing in anticipation of discoveries that could either validate conservative scientific perspectives or confirm humanity's deepest anxieties regarding visitors from the void. The initial detection originated from the European Southern Observatory's Very Large Telescope in Chile at 1423 Universal Time. Dr. Thomas Puzier, who had been monitoring the anticipated emergence zone for over 48 consecutive hours, observed his computer screen as a faint point of light materialized precisely where orbital mechanics predicted 3I Atlas should reappear. For 37 seconds, the universe held its breath as spectroscopic analysis commenced processing the first light from this cosmic sojourner since its disappearance behind the sun. Then the data began to arrive, and everything changed irrevocably. 3I Atlas had survived its hidden passage, but it was no longer the same entity that had vanished behind our star 6 weeks prior. The spectroscopic signature displayed dramatic alterations in chemical composition, with novel molecular emissions that had never been detected during its approach phase. Most disquieting were the isotopic ratios, which now exhibited signatures consistent with nuclear processes occurring at temperatures and pressures unattainable by natural comet nuclei. Something had transpired during those concealed weeks that profoundly altered 3I Atlas at the atomic level. Dr. Martin's Center, coordinating observations from the James Webb Space Telescope, confirmed that the object's infrared signature had undergone a complete transformation. Where Webb had previously registered the familiar spectrum of sublimating ices and organic compounds, the re-emergent 3I Atlas displayed thermal emissions indicative of internal temperatures far exceeding what solar heating alone could generate. The object was producing its own energy through processes that remained entirely enigmatic. The trajectory analysis delivered the news that government officials had secretly hoped to avert. 3I Atlas was no longer following its predicted hyperbolic trajectory toward interstellar space. Instead, orbital mechanics specialists at NASA's Jet Propulsion Laboratory calculated that the object had successfully executed what could only be described as a reverse solar slingshot maneuver, utilizing its passage behind the Sun to break free from escape velocity and establish a stable orbit within our solar system. Avi's most alarming conjectures had been mathematically substantiated. The confirmation that 3I Atlas had deliberately altered its trajectory sent shockwaves through government command centers worldwide. This was no longer a matter of scientific interpretation or academic discourse. An object possessing demonstrably artificial capabilities had taken up permanent residence in humanity's cosmic vicinity, and its intentions remained entirely undisclosed. The metamorphosis from interstellar visitor to solar system inhabitant represented a fundamental shift in the relationship between humanity and whatever intelligence might be directing this mysterious wanderer. Ground-based radar installations detected structural modifications in 3I Atlas, suggesting the object had undergone significant physical alterations during its hidden transit. What had initially appeared to be a relatively compact cometary nucleus now exhibited evidence of deployed structures extending far beyond its original confines. The radar cross-section had increased by over 300%, indicating that 3I Atlas had either deployed previously concealed components or manufactured new structures during its sojourn behind the Sun. The radio emissions that had perplexed researchers throughout the summer had evolved into something that could no longer be dismissed as natural phenomena. The Very Large Array in New Mexico detected intricate modulation patterns exhibiting mathematical structures characteristic of information encoding and transmission protocols. While the signals remained within frequency ranges theoretically attributable to plasma interactions, their organization and timing suggested an artificial intelligence engaged in systematic communication with unknown recipients. Dr. Seth Shostak from the SETI Institute found himself at the forefront of humanity's first confirmed encounter with extraterrestrial technology. The radio signatures emanating from 3I Atlas met every criterion that SETI researchers had established for identifying artificial signals from alien civilizations. The patterns included prime number sequences, fundamental mathematical constants, and what appeared to be deliberate attempts to establish communication protocols with any intelligence capable of detecting and deciphering the transmissions. International space agencies faced the unprecedented challenge of formulating response strategies for a permanent alien presence within the solar system. 3I Atlas had positioned itself in an orbit that would bring it relatively close to Earth every 14 months, creating regular opportunities for either peaceful engagement or potential aggression. The objects demonstrated technological capabilities, ranging from chemical processing to trajectory manipulation, suggested it could pose existential threats to human civilization should its intentions prove hostile. The chemical weapon production that had caused such alarm during 3I Atlas's approach phase had not ceased, but had evolved into something even more disturbing. Post-perihelion spectroscopic analysis revealed that the object was now manufacturing compounds that had never been observed in nature, exotic molecules with properties that human chemistry could neither predict nor comprehend. These synthetic materials were being released in controlled quantities, as if 3I Atlas were conducting atmospheric engineering experiments or preparing chemical tools for purposes yet unknown. NASA Administrator Bill Nelson convened emergency briefings with world leaders to discuss humanity's response options for a permanent alien presence within the solar system. The discussions, conducted through secure channels with classification levels exceeding those for nuclear weapons protocols, explored scenarios ranging from overtures of peace to preemptive military action. The realization that humanity was no longer alone in its solar system had transitioned from science fiction speculation to urgent policy decisions that could determine the species' survival. The global community was divided between those advocating for immediate communication attempts and those warning that any contact might provoke retaliation from technological capabilities that could annihilate human civilization within hours. The debate mirrored deeper philosophical inquiries concerning humanity's place in a universe that clearly harbored intelligences far surpassing anything Earth had produced during its brief history of technological advancement. 3i Atlas had answered some questions while posing others that would undoubtedly haunt human consciousness for generations. The object was definitively confirmed as artificial, vindicating researchers like Loeb, who had endured ridicule for suggesting the existence of alien technology. However, its purposes, origins, and intentions remained as enigmatic as ever. Humanity now understood it was not solitary. But this newfound knowledge brought apprehension rather than wonder, as the implications of contact with a superior intelligence became increasingly stark. The economic ramifications of confirmed alien presence began to ripple through global markets as investors recognized that human technology might become obsolete overnight should 3i Atlas elect to share its advanced capabilities. Concurrently, defense expenditures surged as nations prepared for potential conflicts against weapon systems operating under physical principles beyond human comprehension. The confirmation of extraterrestrial intelligence had paradoxically engendered both unparalleled opportunities and existential threats that no human institution was adequately equipped to manage. Religious and philosophical bodies grappled with integrating the reality of alien intelligence into belief systems formulated during humanity's era of cosmic solitude. The knowledge that advanced civilizations had existed and operated within the galaxy for billions of years challenged every tenet of human exceptionalism and divine purpose. 3i Atlas had compelled a species-wide confrontation with cosmic insignificance, testing the psychological underpinnings of human society. The object's persistent presence in Earth's vicinity created an enduring state of uncertainty permeating every facet of human planning and development. Long-term initiatives, from space colonization to technological research, had to now factor in the possibility that alien intervention could render all human endeavors superfluous. The future had become fundamentally unpredictable in ways that challenged the foundational assumptions of civilization itself. Educational curricula worldwide began incorporating alien contact protocols and xenobiology for children who would grow up in a universe known to harbor superior intelligences. The generation born after 3i Atlas's arrival would face challenges unprecedented in human history, demanding psychological and intellectual preparation for realities that transcended the scope of all prior human experience. As 3i Atlas continued its silent orbit around our sun, concealing within its mysterious structure technologies and purposes tantalizingly beyond human grasp, it served as a perpetual reminder that the universe was far more alien and perilous than humanity had ever conceived. The questions it raised concerning intelligence, technology, and survival among the stars would define the next epoch of human civilization, assuming that epoch would indeed be authored by human hands rather than by alien minds that had traversed the cosmos since before Earth's inception. The arrival and confirmation of 3i Atlas as an artificial intelligence originating from beyond our solar system marked the conclusion of humanity's cosmic adolescence and the commencement of an uncertain adulthood within a galaxy populated by intelligences possessing capabilities bordering on the divine. Whether this transition would lead to transcendence through communion with superior beings or annihilation at the hands of predators beyond human understanding remained to be determined by events that would unfold in the shadow of an alien artifact that had chosen our solar system as its new home. The questions that would forever haunt humanity had been answered, but those answers had unveiled a universe infinitely more intricate and terrifying than any science fiction author had ever dared to imagine. 3i Atlas had brought humanity face to face with its own cosmic insignificance, and the species would never again be the same.